think we can start. It's 9:30. So, Assalamu alaikum. Good morning, everyone. My name is Gaith Al-Sahib, and I'm the Business Development Manager responsible for the transportation and logistics sector at Saudi Arabia. Also today, I'm joined with my colleague, Christelle. She is the Utilities and Telecom Business Development Manager. Christelle today is going to walk us through a presentation where she will share some of the challenges that the industry faces. In addition to that, she will also share some compelling use cases on how GIS can overcome those challenges. Just to let you know that the session is going to last for almost 45 minutes, followed by 10 minutes Q&A session. Also, due to the high number of attendees, you will find the URL links sent to your email. So we're going to be live streaming that session as well. And of course, at the end, we're going to have, as I mentioned, 10 minutes question. If we're not going to be able to address those questions, please feel free, after the session, to meet and check up those things. So, without any further delay, please join me in welcoming Christelle Ortsig.
Gaith. Okay, good. All right, 1, 2, 1, 2, working? Yes? Looks like the technical issues might be with us, but hopefully not. So my name is Christelle, like Gaith mentioned. I'm so happy to be here again. Last year, we had quite a few sessions related to utilities and telecom, but this time we decided to do a little more, around infrastructure and infrastructure management. And that's because, of course, what's happening in Saudi, the vision for 2030 is such that there is infrastructure development everywhere. Just take from the airport to here, it's obvious that development and infrastructure development is happening everywhere. So we're going to talk a lot about infrastructure. That's going to be covering airports, seaports, telecom, utilities, sewage, including rail. There is a new metro now that is on as well. And also we are going to cover things related to facility management for sports. Of course, the World Cup for 2034 is going to be hosted in Saudi, which is great news. And of course, GIS can very much be used to support all of the life cycle of the development of those facilities. So I have a lot of ground to cover. I will try to be within the time. My colleague Gaith will help me out just in case I go overboard. But we'll also have one of our customers here, the Royal Commission of Yanbu and Jubail, who will be presenting. So we'll start first on why GIS for infrastructure management. And I'm guessing in the room, if you're here, it's because either you're already using GIS or you have plans to do so. So who's using GIS already? Wow. Okay, good. So that's very good. So you know why you need to use GIS, right? But if you're using GIS, I want you to reimagine how you can use GIS for infrastructure management if you're already using it. And if you're not yet using it, I want you to imagine a world where actually, if you heard the plenary yesterday, Jack Dangermore mentioned GIS and everything, right? So GIS can be used for everything. Same thing here. I want you to think about everything about your infrastructure and how you can use GIS for the full life cycle from siting, planning, and throughout the build and the construction, the build, the operation, and the maintenance of your infrastructure. So effective land use planning is essential. I will start with land use because of its space, and having the space to put your new infrastructure and the development of your new project is very important. Without the space, of course, there will be no new projects, and it's hard to do things when you have also a limited space. In Riyadh, it's quite congested now, so we can see most of the development happening in the north of Riyadh or surrounding the city. Of course, it's not just Riyadh, there is the entire kingdom that is being developed. So space is definitely essential, and the management of the land use and land use planning is super essential. We will have actually a presentation from our customer Royal Commission of Jubail, Mr. Ala. Please, can you please share your story on how you're using land for your... It's an industrial city that is managing. Please, Mr. Ala. Mike? Yes.
السلام عليكم ورحمة الله وبركاته. صبحكم الله بالخير جميعا. نرحب بالحضور. نشكر لإزري السعودية هذه الفرصة المناسبة
Commission. Yeah, we're gonna check. Is this better? Yeah, okay.
السلام عليكم ورحمة الله وبركاته. واضح؟ صبحكم الله بالخير جميعا. شرفتونا وشاكرين لإزري السعودية هذه فرصة مناسبة لنعرض ما لدينا في الهيئة الملكية لجبال وينبع. Hello everybody. Thank you and I'm pleasure to welcome you in Esri Conference Saudi Arabia. First of all, I would like to being here today and appreciate your coming. Our application called WSOF Geoportal. First of all, what is the Royal Commissioner? We want to give you full or view vision for what is the Royal Commission. Royal Commission for Jubel and Yombo established around 1975, developed and managed major industrial cities in Saudi Arabia. Today, RCJY oversees 4 cities, Yombo and Jubel and Ras Al Khair and Jazan. Industry and life, this is the logo of Royal Commission. Reflecting and commitment to creating industrial cities with highly quality living. RCJY vision to be global leader in the development sustainable industrial city, driving economic growth and improving the quality of life. We want to tell you what is the tour for WSOF journey. The journey for WSOF started with challenge of handling the hard copies of as-built drawing, which led us realizing the importance of digitalization. So we started to digitize the hard copy along with other format like CAD-based files to put them all in enterprise geodatabase. Then WSOF came into picture to bring all the data under one user-friendly web application. See, this is the essential layer for GIS geodatabase. We have geodatabase those we used in WSOF, the satellite image, utilities network, the premises and the administrative boundary. Here you can see the simple demonstration for data conversion process that took place to build the geodatabase, starting input and digitalization to the RCY geodatabase. During the conversion process, the most important part is the attribute table, the attributes to be filled. See, this is the hard copy was, and this is the attribute what we filled it. We currently, this is how data look like after conversion. It contains the potable water, the irrigation lines, fiber, telecom lines, electrical lines, storm drainage, and the sanitary sewer. The geoportal WSOF, we currently have 3 different interfaces for WSOF to give more customized feeling to the user. The geoportal phase 1 is developed and consists of 2 interactive maps, which are the project and investment agreement. The second phase will be hold the product pipelines and premises information interactive maps. The third phase will be have RCY assets, information for the assets, investment opportunity, RCY city panorama, and the utilities network. Really, this is the project interactive map which show the dashboard containing all the project of RCY and their location on the map. This is the investment agreement, interactive maps which show all the location of the investment agreements along with all related attributes and their attachment. As you can see, the legend below show the contracts and the end of this contract, all the agreement reflected on the map to help the user identify the expired contract and take the necessary action. This is how the utilities network interactive maps will look like when released. At the end, must highlight and thank Esri for their provided technology that made all of that possible to have today. This is the video for Wusuf.
مرحبا، أنا وصوف. أهتم بإبراز البعد المكاني لأي معلومة أجدها في طريقي، ويسعدني أخذكم في جولة تعريفية على خرائط التفاعلية التي أجمعها في بوابة الجيومكانية، ومتحمسة لأعرفكم على أولى خرائط الجيومكانية التي أنتجتها. هذه خريطة المشاريع التفاعلية، جمعت فيها بيانات جميع المشاريع التي تقوم الهيئة الملكية بتنفيذها، وربطت كل مشروع بموقعه الجغرافي، كما أضفت بعض الأدوات التي تساعد ملاك هذه المعلومات لتحديثها على الخريطة واستعراضها على لوحة معلومات. ضمنتها عدداً من الرسوم البيانية التفاعلية لتساعد الإدارة العليا في استعراض المشاريع بشكل تفصيلي ومتابعتها لضمان اتخاذ القرارات المناسبة في الوقت المناسب. وقد لاحظت أن المختصين بقطاع تطوير الاستثمار يبذلون جهوداً مضنية في سبيل متابعة العقود الاستثمارية، لذا قمت بربطها بمواقعها الجغرافية مع تمييزها بألوان تعبر عن المدد المتبقية لها، كما قمت بإتاحة تحميل وثائق الاتفاقيات للمختصين للاطلاع على ما فيها من التزامات، كما أقوم بتذكيرهم برسائل إلكترونية قبل انتهاء الاتفاقية بوقت كاف. وهناك الكثير من الخرائط التفاعلية في جعبتي، سأحرص في قادم الأيام على تغذية بوابة الجيومكانية بها. آمل أن تكونوا قد استمتعتم بهذه الرحلة الشيقة، وأن أراكم قريباً في بوابة الجيومكانية، وأعدكم بأنكم ستجدون لدي أدق المعلومات الجيومكانية وأحدثها عن مدينة ينبع الصناعية. مع السلامة.
Finally, really I'm proud to be part of a great team. سمية، ناصر نبيل، وائل البكري، سلطان، Engineer Ahmed, Sami Al-Irwi, all of our great team. If you have any question, I'm very happy to answer it. Thank you very much.
Thank you so much, Mr. Ala. What a great presentation, and an example really when it comes to, keeping an eye on the land, the availability of the land, and the space available for any additional investors or projects to be put in the industrial area of Royal Commission of Jubail and Yambu. Mr. Ala, how much time did it take you to put this system in place? 6 months. So when we see where you started from with all of these paper maps and CAD drawings, it's really amazing. Fantastic job. Thank you so much. Thank you. So now I'd like to switch gear a little bit and talk about some other work being done when it comes to the space available within a specific place here in Riyadh. And I'd like to actually, I guess my colleague, my friend Abdel, are you here, Abdel? Yes, Abdel. This is the work of Abdel. Thank you so much for sharing your work as well. So Abdel has done, he works for CAPSAC. I'm sure you're all familiar with this entity here in Saudi. And he did a study on how to leverage GIS for off-grid electrical vehicle charging in Saudi Arabia. It's fantastic work, because one of the challenges that there was is there space available in Riyadh to be able to put that infrastructure in place, it's one thing to say I'm going to put green infrastructure out there, but if you don't have the space, again, you're going to be stuck, right? So that's the great work that Abdel has done. And please, if you have any questions about this work, get in touch with him. And he's done a lot of scenario and analysis on what would be, the most optimal way to put, either hydrogen or variety of type of green infrastructure in place. So great work. Thank you so much for sharing, Abdel. Now, we've seen a lot of things in 2D over the past years. And there was a reason for that, right? The technology and the way we were capturing the data and visualizing the data was very much in 2D. But really, now we can see that the trend is very much towards 3D. So for the rest of the presentation, you're going to see a lot of things that are going to be digital twin, 3D representation and visualization. And I really encourage you within your organization to take really a good look at all of the available content, either from other entities within the kingdom, or from our Living Atlas, if you wanted to. So here, this is a screenshot of what we call the OpenStreetMap. This is embedded into ArcGIS Online. You can have it. You can have access to it if you're a part of. You have access to our technology. And I would just want to show you live how it looks like. Just one second. Up. I just have to bring it here to you, and you can see here how dynamic it is. So this is like around the hotel here in Fairmont, and this OpenStreetMap layer is not only a 3D layer with the buildings, but it also contains the green, the greenery. So if you have some trees, of course there are many projects in the city of Riyadh to have the city a bit more green, so you can have that also represented, and it's available for you to use. What I like about this data set is that it's not intrusive. By this I mean that you can start already to have contextual information that is very easy for you to use, and then you can lay over, even if it's 2D information, but you can maybe make it Z-aware over time and bring it to the display whenever you engage with management. Management will relate better to this type of representation. It doesn't have to be the full reality capture type of representation with all the buildings and the detail of the buildings. Already this is a very good start. So I really encourage you to take a look at this one. And for those of you who are dreaming to see snow in Riyadh, we can make it happen for you. Okay? There is this beautiful here weather thing, and off you go. So, or maybe you prefer the sun. It's up to you. I think you get a lot of sun during the year. All right, enough jokes. So let's just go back to the slides. Okay, so obviously Saudi Aramco using a lot of GIS technology for many years, and they continue to use it for a variety of things. They also opened up a new imagery unit, so they do a lot of AI analysis on it, but primarily for oil and gas infrastructure, you're looking at monitoring the pipelines, maybe also looking at the clean energy transition and supporting a variety of analysis in order to see where you can maybe bring some clean energy and transition to it. Emergency response, this is more on the operational side of things, so in case of emergency, a leak or any type of issue, and that can be internal or external type of problem that can come to the infrastructure. Now let me show you an example of situational awareness for gas pipeline.
A GIS-based digital twin provides a common operating picture for onshore operations. Real-time and IoT sensor feeds can be ingested and visualized on the map to provide enhanced situational awareness. For example, SCADA feeds can be used to identify assets in an alarm state, like this facility with a high pump temperature. Various other alarms can be highlighted across the bottom, allowing a user to understand what sites are experiencing issues. Here we see a separate well site with a high gas to oil ratio. A configurable pop-up can display key information like dynamic sensor readings, along with other real-time information like the location of the nearest worker that could potentially be used to address the issue. Other alarm types can include emissions-based alarms that might indicate locations experiencing high concentrations of methane or other harmful emissions-related gases. We can also see tank alarms that indicate the location of tanks that are nearing capacity. And this information could be used to identify the nearest worker or dispatch the appropriate resources to address the issue and decrease the capacity of the tank. We can also incorporate weather information so that we can understand which field workers are impacted. In this case, we're using lightning strike data to understand which workers are in close proximity to lightning strikes, and even send alerts to those workers telling them to seek shelter. Beyond real-time data, historical big data can also be integrated into a digital twin.
Jumped a little bit, but never mind. Okay, so I'll just move on to the next one. So now let's talk about the utilities a little bit. Of course, many organizations and utility companies worldwide are using GIS for mapping their grid. We will have a session, and the next session will be on network management. So we're not going to talk about the typical uses of GIS for managing the network. This will be the next session. But of course, you can use it. A lot of organizations, also utilities, are pushing things to be more, and having green energy, so renewable integration as well, so supporting solar and wind farms, so that it's used a lot for planning this. And efficient operation, of course, managing the load and load efficiency, fault detection, and so forth. This is very much used in that way. For water infrastructure, of course, leak detection is one thing, but knowing where the leaks are happening and making sure that anything around those leaks are not damaging any more other infrastructure as well. Conservation projects, of course, is a big thing, and is also on the agenda of the Saudi Vision 2030. For sewage, definitely, oftentimes we think about when there is new development, we think about the utilities, about electricity, water, and telecom, but what about sewage? I mean, sewage is a big thing, right? If you want to make sure that people are happy living in a place, the sewage network needs to be properly designed and built to support the population that is in this location. Now I want to show you something that is encompassing all of the utility networks and much more than that. And also at the end, I want to bring some external factors and to do some flood simulation. So let's have a look at how that looks like.
With ArcGIS, we can view all types of 3D data. So let's begin in the background with the 3D base maps, where we see schematic buildings and trees to represent the city. And for more detail, here's a 3D mesh based on drone imagery from our partner, Winthrop. The 3D tile capabilities on the web allow us to view transportation data from VBZ, like these columns and these overhead tension lines in green, these trolley bus cables in blue, the tram cables in orange, and the power feeders and lines in yellow. This network has assets that are hidden and can't easily be seen while walking down the street. By using tools like slice objects, we can cut through various layers to reveal the underground assets, like the maintenance holes in purple, the electrical conduits in red, and the drainage system in blue, all beneath the surface, truly representing the real world. We can also add BIM models, like this one of the Zurich train station. Combining BIM and GIS makes it easy to see the spatial aspect, as well as the detailed design of the exterior, the interior from the floor to the ceiling, and anything in between. We can compare these digital designs to the construction using LiDAR scans by overlaying this point cloud layer. This helps us detect any indifferences verifies the construction, and ensures a parallel 3D digital twin. Let's now leave the station and slowly glide up the hill to find ETH University. These digital floor plans can allow us to see the layout of single and/or multi-floor buildings and facilitates navigation across all levels to identify critical assets like Albert Einstein's locker, which remains intact to this day. Let's continue at the Letzeturm building and focus on the indoor utilities that crawl throughout the building and examine this heat exchanger. In this pop-up, we find data from many different enterprise systems like asset and work management or CRMs. The cost details show $390. With seamless integration to web apps and systems like ServiceNow, we can adjust that price to $425 to simplify our workflow, update that information, and see that change in near real time. This ensures data integrity, and it also aligns your enterprise systems. Moving on, let's analyze and simulate the interaction between the environment and infrastructure in 3D. This map represents the heat island effect in Zurich. The blue and yellow areas show cooler temperatures, like at this waterfront park, due to the shade provided by all these trees. In contrast, the red areas show high temperatures, like in and around the train station. In order to beat the heat, the city wants to plant trees nearby. While this offers a solution, it also poses a risk to nearby assets. So let's take a closer look, and by adjusting the base map transparency, we can see underground the pipelines of the water and fire suppressant system, and these yellow buffers indicate how far the roots need to grow for the tree's survival. With this data, how can we analyze the long-term relationship between nature and infrastructure? With 3D analysis tools, we can highlight the areas here in red to show where the pipes and the roots intersect. And with the growth rate for each tree, we can add time to our data and use the time slider to see and simulate the impact over the next 50 years, showing a significant part of this corridor poses a huge risk. These 3D results can provide important information when making decisions to develop and create green infrastructure well into the future. Finally, I have one last scenario to show you, and let's focus on the element of water. There are 3 major bodies of water near the city: the Lake of Zurich, the Limmat, and the Ziel. The Ziel flows through the mountains and through the town, and even underneath the train station. In 2005, heavy rainfall caused the Ziel to reach its capacity along the banks, endangering infrastructure like the station, roads, and bridges.
Let's eat on
The water flow reached about 300 cubic meters per second. That's similar to when opening up a dam. So let's test the river's capabilities and capacity and up that scenario to 400 cubic meters per second and simulate it using the ArcGIS flood simulation tools in 3D. This animation and these results show 2 vital pieces of information. 1, how water moves and floods various parts of the city. And 2, the impact area and all of the structures within it. The darker structures, like the station to the south, are especially vulnerable. The city of Zurich has done extensive research on this model, and the damages to the train station alone are upwards up to $7 billion. $7 billion. In order to safeguard Zurich, we can develop infrastructure upstream, like this culvert relief tunnel. This BIM model shows us the details of this tunnel. It only opens up and diverts water when water levels are exceptionally high in order to accomplish a smaller downstream flow rate. With our 3D digital twin, we can navigate the underground tunnel where water flows solely due to gravity, down 50 meters of elevation in over 2 kilometers, and empties out 90 meters into the Lake of Zurich. This is a real-world project estimated to be completed within the next 2 years, capping water flow at 300 cubic meters per second and ultimately saving billions of dollars to damages to the city of Zurich's infrastructure.
So as you can see here, why I mentioned early on 3D, you can starting to see that it's not just above ground, right? It's also underground. We saw how to, if you put green infrastructure, how you can also plan and predict the impact of the green infrastructure on the existing infrastructure. So, this is really what I meant by initially saying, reimagine how you can use GIS today. No question you are using GIS, you will continue to use GIS, but giving you some ideas and new ideas on how to leverage really the technology going forward. And if you want to do more with flood and flood modeling, apart from the flood simulation, you can do a lot of representation and visualization with other information related to your buildings, for example, or your other assets. There was a big event of flood. I live in Dubai, so there was a big event of flood last year. I know there was also in Riyadh, and we expect more and more. It's just switch on the news, you know the problems everywhere, whether it's drought and fires or flood. But I think here it's more flood that will be the issue going forward. So telecom, we can do a lot of things with telecom. I don't know if telecom companies are here in the room, but obviously they do a lot of things related to 5G network optimization, where to put it, mapping their existing network, and also trying to provide the best service to the customers, but whether it's B2B or B2C. I want to show you quickly, the various type of data that are being used, and also how to kind of create that 3D view of, your network and your environment.
3D objects. Yeah, as part of a telecom network, there are hundreds of data variables to consider when either expanding or densifying a current network or building a new greenfield network. And I'd like to show how we can combine different types of data to create this digital twin. Let's first start with understanding our current asset footprint, looking here at distribution cable and cell site locations. These become the vital foundational pieces to creating spatial relationships between your network and outside variables, ultimately allowing us to make decisions. You can also add some environmental variables that are important to network planning. Here we have a digital slope model that helps us understand elevation and topography, as well as clutter data shown here, which classifies different types of land use and cover used in RF engineering and propagation modeling. The RF engineering results can be viewed in our digital twin to help individuals in your organization understand the covered and serviceable areas of the network. Shown here, we have an RSRP layer displaying signal strength in varying shades of green. We can leverage this data to move into a three-dimensional world of data. And we can now begin to use extruded building footprints to understand the same RF coverage as it pertains to each structure shown here, and view underlying attributes, including the number of employees, businesses, total bandwidth, and RSRP levels. This even allows us to view signal strength at a floor-by-floor level shown here. As the world shifts to 5G and millimeter wave, we need to model the environment with even higher accuracy. LiDAR point clouds captured from vehicles, aerial drones, and even smartphones can provide highly accurate 3D and height measurements of the environments. From this data, we can use spatial analytics and machine learning tools to create 3D objects that store info about each feature in a database. After establishing these models of the surrounding landscape, we can dive deeper into building information models. This can include the entire building structure or a specific asset and infrastructure that's connected to the network. Here's an example of a rooftop containerized cell tower that shows the overall constructed layout for field engineers but also contains asset attributes vital to the operations team, including site ID, type, and owner. Moving out of the more urban environment, we can view another cell tower here connected to distribution cable. We can perform a virtual flyover to assess the tower, as well as view antenna information we mentioned earlier. These immersive web-based views allow more actions to be taken from a computer and reduce the amount of site visits needed, therefore helping to increase the sustainability metrics of your organization. Lastly, in terms of building information models, we can look into the anatomy of a specific building structure and the configuration from a layout perspective as it pertains to the network. These complex building models can include floor plans and 3D models generated in CAD technology. We can see various places and things laid out in this building, but also overlay our network information to understand ISP operations. We can see our fiber drop as it runs up the building and eventually connects to a server room. As we've shown with other 3D models of the network, we can select these assets and view underlying attributes to understand, assess, and take action.
You can see here how slowly they built, the digital twin, starting with some various layers in 2D, and then bring some just building footprints, and then bringing more like the reality view of the buildings, outside plant as well as inside plant. Now, another big piece of infrastructure is also data centers, right? So, especially with AI, many data centers have to be put in place. So, GIS is very much typically used to kind of take a look at monitoring the temperature. Of course, that's very important of those data centers, but not just that. So let me show you a quick video of how you can use GIS for data centers.
In addition to monitoring energy consumption, we can see real-time alarms or alerts. These alarms could be temperature spikes inside of our data centers or faulty network equipment. Central Office number 2 currently has 3 power alarms. Let's zoom in to inspect the situation. We can see a floor plan of our office, as well as the outline of our racks containing the temperature sensors. Our real-time temperature feeds are overlaid on top of the floor plan to create a heat map view of the current temperatures, row by row. Down in the right corner, we can also get a status update of the overall temperature inside the central office. Monitoring all of these different real-time feeds, along with our assets inside GIS, allows us to create an operational view, or a digital twin for our network teams. This can help optimize energy efficiency, monitor performance, identify faults, outages, or performance degradation. Notice how all this was done in 2D. If you want to get a closer to real-life view of central offices, ArcGIS supports modeling a digital twin in 3D. It allows you to bring in BIM models, CAD data, point clouds, and
Sorry, it jumped. Let me just go.
models, CAD data, point clouds, and reality capture directly into 3D web scenes and applications like this one that you're seeing here.
Okay, so there is more for telecom. Is there a telecom organization here in the room or not? No? Yes? Which company? STC, okay. Maybe we can talk about this one afterwards, but the idea is to kind of show from a KPI perspective, enhancing the customer experience for the customers. But I'm going to switch to that because I have much more to present on other things. Okay, we'll talk later. Thank you. So let's move now to transportation infrastructure. We're going to talk about airports and seaports. Just quickly, when it comes to traffic and traffic congestion, Riyadh, same as Dubai, very problematic. So we can do a lot of things, slicing a lot of data related to traffic accidents and any historical data available, and then put it in a dashboard. That's not something that is new, but just wanted to kind of show you a couple of screenshots that a colleague of mine has put together in our Dubai office. Okay, so now let's talk about airports. Let's see a few examples of how to use the GIS for airports.
A year ago, we began managing the airspace and facilities at John Wayne International Airport. In April, 1 million travelers came through the airport. To accommodate such travel booms, we designed our GIS applications to streamline the airside, landside, and inside functions of the airport. We looked at our 3D indoors model in ArcGIS to get a better understanding of the inside of the terminal. Our floor plans were derived from BIM and migrated into ArcGIS indoors. Using this LiDAR backpack, we also created a point cloud data set. We do this so we can rapidly update our floor plans and take quick inventory of our assets. OC Survey has a dedicated drone fleet that rapidly deployed to capture imagery of the route. We upload it into a video server and create a side-by-side view of our ortho imagery on the left and followed along on the full motion video on the right. We were able to identify where water was cooling. We placed an observation point, filled out the leak details, and sent the web map and attribute information to our service team.
In Orange County, we are constantly innovating. We're going to continue to invest in new ways of modernizing our GIS workflows, enabling county staff to be more efficient.
And that is the power behind survey and GIS.
Good morning. Tampa International Airport is located on the Gulf Coast of Florida on Tampa Bay. We currently serve more than 23 million annual passengers and have an average of 550 flight operations daily. This includes 5 miles of runway across 3 separate runways, 26 million square feet of pavement, 5,300 lights, and 480 signs. Inside the airport, we are responsible for 4.8 million square feet of interior space. This includes 4 separate airsides with 58 gates, 66 shops and restaurants across the campus, and our new mascot, Phoebe, you can see on the right, which is one of the many public art installations we have across the campus. Operations would go out in their truck on the airfield with the clipboard and note any issues they found. Once the inspection was complete, a service request was submitted to maintenance, and then it was filed away in a box. Utilizing GIS and Survey 123, we were able to streamline this process. This has given us near real-time awareness of our airfield and the ability to visualize issues across it. Operations uses this dashboard to visualize issues on the airfield, notated by the green dots on the map. These are all things that the FAA requires. Safety is paramount here. Wildlife is a big piece of this too. We have a team of wildlife experts that perform surveys on wildlife and analyze their behavior. They utilize this dashboard to help visualize areas of high activity. They can dig deeper into the data and look at the strike-specific data. This also allows people in the office to see what has been found in the field immediately. Similar to the airfield, we also perform inspections inside the airport. They notate safety issues such as cracked tiles or spills, to other issues such as overflowing trash cans. Visualizing these issues on an indoor map and sending real-time notifications has tremendously helped with the speed of action. Taking the data further, we'd be able to predict areas of breakdown on the airfield before it happens, spot areas wildlife are gathering, figure out why, and then mitigate the risk before it becomes a problem. Utilizing analysis to be able to predict these issues and find trends will help us with our safety and customer satisfaction to remain America's favorite airport.
Hello, I'm part of a small GIS team at San Francisco Airport, or SFO, comprised of 3 GIS analysts. And it's our responsibility to map the infrastructure at the airport. We have about 400 miles of subsurface utilities. We map things like potable water, telecom, natural gas, electrical, industrial waste, sanitary sewer, surface assets, storm drain, and aviation fuel line. 18 million square feet, 97 different buildings, floor plans, spaces, levels, POIs, doors, multiple BIM models at once, 9 BIM models, 9 different contracts, hundreds of different architects, 9 different models, all geo-referenced, 8.5 million square feet of BIM.
Dublin Airport it's a big campus. So
one quick demonstration here also for airports. I'll go a little bit fast on this one.
Hartsfield Jackson Atlanta International at this point. Your surfacing tool to intersect the trees with our approach surface, splitting the trees into 2 parts. Those below the surface and those that extend above. We have 468 trees that intersect this approach surface, and now we know exactly what height we need to trim each tree. overlaying parcel ownership, we now know exactly who is responsible for the trees. By the way, for those of you flying through Atlanta, we've mitigated the problems with these trees, and the FAA recently gave us a perfect score on our airfield inspection. The first step used the FAA standard GIS data model and a set of cartographic rules to create our 2D base map. The second step was to add the structures on the airport property. We did this using Pictometry's 3D models for our tower, terminals, and concourses. And now you can begin to see the vivid level of detail, including our gates and our planes. The third step was to use procedural rules to render the other assets like signs and lights. Let's take a quick flight over to Taxiway Hotel and check out the signs. These were constructed from points and attributes in the database and rendered with the 3D rule. Our GIS data now becomes the signs that pilots see every day. To further demonstrate, with just a simple attribute edit, the sign regenerates. We can use the same process, such as passenger boarding bridges, can support these changes. Basically, we just want to make sure the plane fits at the gate. The last step needed to complete our 3D airport was to convert our BIM, or Building Information Model, into GIS features. This allowed us to take 3D GIS inside the terminal. Now, we can begin to explore and see what's under the concourse. We can go through the windows and see what's inside. Or even go below and take a look at our transit systems. These were the 4 steps that we used to create a 3D GIS transformation of the Hartsfield-Jackson Atlanta International Airport. Hartsfield-Jackson.
So now let's talk about ports. I know that we're running out almost of time, so I'm going a little bit fast. So let's go for ports.
Try to delve deeper into our projects, where we utilize all the mentioned survey technologies across the entire project lifecycle, from the stages of planning, design, to constructions and operations. This is Vietnam's largest seaport system on the ArcGIS online platform, with the entire reality capture data of 20 kilometers seaport system along the coastline. We can go into detail and measure all parameters of the port, including coordinates, elevations, area, slope. Thanks to the digitized survey data, we can easily know the current situation of the site without needing to be on site, along with other many layers like 3D point cloud or land use, building information modeling of the master plan, stratigraphic soil profile, paper reports, and research data of this area for the last 20 years are also integrated into this platform. Hydrographic data surveyed by port codes are also converted to 3D terrain and integrated into this platform, and we can easily extract the cross-section any location we want. All information is in one unified data center. During the project design phase, advanced survey equipment is utilized to accurately capture the existing condition of the site, enabling precise analysis and informed decision-making for the project development. BIM design models are integrated. Try to delve deeper into GIS integration.
Sorry about that.
Try to delve. Throughout the operational phase, all information can be stored and updated, making it a valuable resource for ongoing management and maintenance. Activities like conducting periodic survey inspections, implementing redesign strategies to restore structural functionality in case of collisions. Now, the integration of ArcGIS Map SDK for game engines is revolutionizing the creation of digital twins, enabling advanced simulation, monitoring, and IoT applications. It enables us to evaluate designs, alternative, and optimized solutions before the construction phase begins, reducing the risk of errors and rework. By connecting to IoT devices such as CCTV or sensors, urban planners and engineers can monitor conditions in real time. This approach enhances decision-making process, improves public safety, and ensures sustainable urban development. To summarize all of that.
So you can see how advanced some of the implementation can be, you know, in ports or airports. Now, quickly, I know, like, I mean, like.
5 minutes over, so.
Okay, so I will do one last. I'm not going to cover the rail and the metro, but I'll cover the World Cup because, of course, the World Cup is coming here. So we had, of course, during the Qatar World Cup, the GIS, an ArcGIS was used first for planning and siting where to put the stadiums. And then there was application, web application, as well as story maps that were used for anyone who wanted to know where the location of those stadiums, but also for crowd management and safety. So let's look at the
relive the magic
video.
of FIFA World Cup 2022 in Qatar. It began with a spectacular opening ceremony. Fan zones were alive with global excitement. Every match was filled with unforgettable moments. Qatar's stunning stadiums set the perfect stage. Football's biggest stars dazzled with their skills. Advanced security ensured a seamless FIFA group rounds, allowing fans to follow teams between stadiums and fully enjoy the grand finale, celebrating the new champion. Now, let's see the technology behind the event. Precise mapping and real-time tracking enhanced security. The National Command Center and Ministry of Interior coordinated seamlessly. Efficient crowd management ensured smooth operations. Interactive technology boosted fan engagement. ESRI GIS solutions were key to the flawless execution, setting a new standard for global sporting events.
All right, so I think you've seen quite a lot of things today. Just in the interest of time, if you have any questions, but you can see how you can use GIS to support all of the project development, infrastructure development happening in Saudi. The proof was, I think, definitely on stage.
Thank you very much, Christopher.
Thank you.
So now we're going to open the floor for questions.
No question? Okay.
I would like to ask about how to get the resources for all the studies, for the flooding or the stadium studies. Or
Yeah, no problem. We can share contact details and we can share all of this information with you. No problem. Yes.
I know Esri have integration with Autodesk and GeoBIM.
Yes.
What about SCADA system?
Yep.
And another sensors, how to get data and visualize it in dashboard or 3D scene?
Yeah, we have the technology for that. If you're familiar, we have like the Geo Event Server, which is more like for on-prem, but we also have Velocity, which is more online, type of integration. So we can get the feeds from SCADA and then bring them into the dashboard. Which infrastructure are you managing? Yeah, whether it's water, SCADA from water or electricity, anything from SCADA, you can do it. Yeah. We've done it over and over again. Yeah.
Any more questions, guys?
In the next session, I will show one example if you wanted to take a look at it.
Okay, so.
I think everyone wants to go to the next session.
So thank you very much, Crystal.
All right,
thank you for
you.
coming.
Thank you, everyone. Hope you enjoyed it.
Enjoy your day. Thank you.
check one. Bismillah. Bismillah.
session. It was very much broad infrastructure management. Now we need to focus more on utilities and really how to look at the benefits of a modern network management system. And you've all heard about our flagship that is utility network. And oftentimes we have a tendency to just focus on the utility network itself, and we kind of forget the broader picture. So hopefully I will, throughout the next few minutes, take you through a journey of how other customers are actually using the utility network and what for. So hopefully after these few slides and examples, you will have a better sense of how internally to promote this new technology and without going into the technical aspect. My colleagues will discuss a bit more what is this technology about, but let's start with how GIS is used in modern network management. So with me will be Manoj, will support some sessions, the session as well as George will do a demo. Let's just get quickly started. So in terms of agenda, we will take a look at the network benefits for the utility network, and then what is it, that will be Manoj, and the demo will be George. So I will give examples from throughout the world so that you feel like you're not alone doing this. Before I start, let me share with you, and please take this QR code if you can. This is an e-book that we released very recently. It has 25 plus examples of customers who have implemented the utility network. This e-book is focusing mostly on electricity and gas utilities, but we also have one for water. One for water, and we have also a telecom as well ebook. The telecom one has a little bit of modern network management examples, but not just that, because of course telecom companies are also sales organizations. It's a little bit different than utilities, where kind of it's a must. For telecom it's a little bit different. So we have also use cases for other usage of GIS. So let me take you through one first example. This is an organization that is called First Energy. They are basically based in the US. And what they've done, so it's a large electric utility company, right? They have, they cover 5 states, so that gives you a sense of how big they are. Now, the example that I'm sharing with you, it's the integration that they've done between the utility network and ADMS. Okay, that's good, but what for? Typically, utilities are looking at 3 main things to enhance the operation. Great customer service, meaning no downtime, service is on 24/7, and you don't want to deal with whether it's outage or water leak. I mean, customers don't want to deal with that. They just want the service to be on, right? So high customer experience and satisfaction is key. And then the third one, of course, as an organization, you want to be sustainable as much as possible, operationally and financially. So this organization, like I mentioned, they used the integration between GIS and ADMS. What for? What was the purpose of doing this integration? This is all technical. The 2 things they were looking at was they wanted to improve capacity planning and load management. These were the main 2 business requirements that they didn't have requirements to, and woke up in the morning say, I'm going to implement utility network. No, that does not happen, right? They had a system already in place, which was ArcGIS, the older technology, geometric network, but they needed to have this integration. And as you know, if you have tried to do this integration with the older technology, it was a little bit difficult. Why? Because the match between the data models were not quite there. So doing the integration was a little bit complicated, and from a business perspective, oftentimes the business owners were not that satisfied with the older integration. So they went, and of course the utility network was very much in line with what they wanted to do. The data model enabled them to do that integration in a much easier way. So in terms of
the differences of what is it that the utility network provides versus the ADMS. It's important to understand the mission of the two systems. It's not quite the same. And then we go over why is it that we do the integration. So the utility network, of course, as you know, it will provide you with an accurate digital representation of your grid. And here in this case, it's for electrical grid. Now the detail level, maybe I want you to remember that the detail level doesn't have to be like what we're seeing around us, right? It doesn't have to be that advanced. Detail depends on the requirements and what you want to achieve. Sometimes there is confusion. People are thinking of very advanced modeling. You don't necessarily need to go to that level. And the utility network enables you to go at the level and the step that you want to. From the ADMS perspective, this is real-time operation data that comes from a variety of systems and IoT sensors. So that's a very different type of data that is being used. But the integration between the two, that's really the benefit that you're going to get is, of course, operational awareness. You're going to be able to do advanced tracing and simulation so that you can get inputs in terms of how to do fault prediction and balancing the load. That's really, again, remember, that's what they wanted to do, better load management. And of course, they would allow for seamless decision making based on the two type of data sets being integrated together. So the load redistribution and the load balancing, that's really the main key thing that drove First Energy to do this integration. The second one that they wanted to, business requirements they had was capacity planning. So they need to have the detailed data on the grid asset. That was something that they had from the GIS, and then the other piece as well, for scenario testing, they could simulate various scenarios from historical data, and then add the information for capacity planning. So in real time, how the load is going, doing the management of the load, and then on the other side, we have capacity planning. Am I at full capacity or not? Especially if you are investing into additional development of the infrastructure. I'll just go quickly here on this, just to summarize, the various type of data sets here that they are using. They are just seen here on the screen. But external data sources is also something that they've been adding, and I'd like you to maybe take a note of that. I've seen, I've been at Esri for 22 years now. I've seen implementations throughout the world, and the one that I've been using, weather data services, are primarily based in the US. And there is a reason for that, right? The reason is mainly because, of course, they are facing a lot of, hurricanes and wildfires. Just switch on the news, right? It's happening. But remember, it happened also not that long ago, last year, in Dubai, as well as Saudi, in Oman. We have some episodes of floods and rains, and it's not easy. So bringing weather data information into your various enterprise systems that you have, and the GIS included, that's very essential. And of course, population and development forecast, which is very useful as well here for Saudi Arabia. Okay, so benefits of the integration, we already talked about it, so I'll go quick. Now I want to give you another example, and this time it's a company in Lithuania. It's called ES4, that's the energy distribution operator over there. So they were looking at something a little bit different. They wanted to improve the time it takes for a customer to do customer connection. As you know, especially if you have investors from outside, they want to know, is it easy to do business in Saudi? Meaning, can I get easily access to infrastructure, whether it's telecom, water, electricity? So there is, some metrics for this. So internally, they wanted to improve the time to do customer connection. And of course, the underlying use was ArcGIS as well as the utility network that they put in place. So they put in place this digital self-service platform. You can see here a screenshot of it. They automated various workflows, so that there was a lot of business rules embedded, so that when a customer was requesting a customer, whether it was a business customer, whether it was an industrial customer, whether it was a commercial customer, or just a residential customer, they could support all of those workflows. And the other piece as well is that they are leveraging the technology for field operations. So if you ask for customer connection, of course there will be some processes internally at the utility that will trigger some field activities and operation. So I want you to also think about not just modern network management and focusing on the mapping and the utility network. I want you to focus and think about the entire ArcGIS system that also has, a portfolio of field application to support all of the activities that is also in the field and taking all of the network asset location in the field. They also did very similarly to First Energy. They had the requirements to better improve the management of the load, and that's also something that they've done. So the way they've done it was a little different than First Energy. They see integration. That was something that they felt was easier for them to do this integration between GIS and EDMS. So different technology and ways of doing that, but kind of the same end goal. So better customer connection, the timeline to do that, as well as the load management. One of the things as well, I don't know if you know this, but there is a way to measure how fast you can get customer connection in the country, and for them, they are ranked in the world number 15. So that tells you, that's a very good ranking, to be honest. I forgot the ranking for Saudi Arabia, but it's a very good one too. But you can keep improving.
That's the technology that can maybe also help you go higher in the ladder. So some of the data that they use are a little bit similar to the first example I gave at First Energy. And this is also, the intake. In the world. Now let's talk about water. So this is, if I can pronounce it well, so this is a company that is located in the city of Sofia in Bulgaria. We refer them as Veolia, but this is Sofijska voda for those of you who speak Bulgarian. So some of the challenges they had were a little bit more technical initially than business oriented, because they had the system in place for 10 years. So they knew, how to use the system for managing, the water leaks and all the issues related to water and non-revenue water. But some of the issue they had is that because they started very early in the days, they didn't have, they had like web app plugins and application. Everything was so old and obsolete that they had to revamp and rethink and modernize not only the applications, but also the data. So that's why they opted for the utility network and had a better model, and also for the field. They really needed to have this field, the data being taken to the field, and a variety of tracing in the field as well. They connect with several IT systems. They used to do it before, but now they do it in a much easier way. Because data models, they speak a little bit easier between themselves. So that's a very good example of Veolia. Another one, that's a Dutch one. In the Netherlands, that's the company called Dutch Water. For them, it was also the customer satisfaction business driver to implement the system a little bit differently. And the way they were thinking of it, because they also produce water, so they produce water and they distribute the water. But the way they were looking at things is, we don't want the customer to call us when there is a problem. We should find the problem first ourselves and deal with it internally. Customer will not even notice anything, no disruption of service. So this is just to tell you how really customers are looking at enhancing the customer experience and the customer service of the organization. So, as a customer, I never have to complain, because it's bad, you have to pick up the phone, or there are different channels now and means to do this, but you don't want to waste your time now, especially with the lifestyle we all have. Everything is going fast. You don't have time to deal with a water leak. I personally had the experience recently to have one, and I had someone for 1 week digging, trying to find this leak. There was no leak, but they changed the valve. Eventually it worked. I think the valve was faulty. But sometimes we think of the water mains, and sometimes it's in the valve themselves. It was not even the valve at the meter level in my house, but it was the irrigation valve. So just to tell you.
11 days, and it cost me a lot of money. I kept getting consumption alerts, high consumption alerts, but hey, that's how it goes. And of course, you don't want to have that experience. So Dutch water company has managed to avoid this type of situation. You can't avoid water leaks and water problems. It's impossible, right? Even if you're putting out there a modern water grid, regardless, you will never be able to avoid water leaks. But at least you can try your best to contain, not the fire, but contain the leaks internally in the organization. They also have, you can see here in terms of results, they have improved data quality. That is very important because of the integration with other systems, but also for the people in the field. That's the thing, so oftentimes we think of integration and maybe that's, we need a better quality of the data. That's really the people in the field that need that quality of the data. So again, think of not just the utility network for modern network management, but think more about the business requirements and think of the overall ArcGIS system. Just quickly to finish, I'll show you one example. This was done by Etihad Water and Electricity because these were examples of outside of the Gulf countries. So I'll just show you something. This is a proof of concept done by in the UAE by Etihad Water, and they were just trying to see and experiment how they can do this. The videos now. The video, maybe Manoj, you can help me trying to run it. Thank you. Yeah, this one sounds fine. Yeah, it's running slowly. So, if you were in the previous session, remember I told you that we used to do things in 2D. Here again, things are more going towards 3D. So this was just before they launched their projects, and I think I saw Florian in the room. So Florian, you're doing a project now, but this was before you guys started the project. Yeah, so they were just trying to model not just the assets, the pumps, and the tanks and so forth, but also you can see, the street lights and everything. So again, trying to give a little bit more contextual information around their water assets. Here again, this was more a technology type of proof of concept as opposed to really looking at all of the business drivers, but now the project is ongoing, and like I mentioned, my colleague Florian here from Vertigus is doing the project. Okay, next slide. Here, we also have customers that take the thing a little bit one step further. So this is an example from Ashghal in Qatar. And they are also using virtual reality to show the assets in a way that is a bit more immersive in terms of representation. So they go above and beyond just the traditional way of visualizing the information, and it's a very successful type of implementation. And the last one, I forgot someone asked me about the integration with SCADA. I don't know if it's still in the room. But here, this is another example of how you can actually, because of the data quality that is much better when you start to move to the utility network, then you can do better integration. So we have the example of how you do for preventive maintenance. Here, this is the use case, preventive maintenance, and then you will want to get the real-time feeds from SCADA. And then in addition, you will have integration with your asset management for the maintenance information stored in the asset management, and of course integration where you can see the representation of those assets. This is BIM data that is brought in. So again, you have a better sense of what is this information and the network around it, and the CCTV cameras that you just saw, right? Various dashboards that can be done as well as a job assignment from this. So that gives you a sense of what customers are thinking and where they're going and how they want to use that. So I hope that that gives you a better idea of how you can use and leverage this utility network technology and promote internally the business benefits of it. With that said, I'll hand over now to Manoj. We'll discuss it a bit more. Oh yeah, before you do that, if you, from an architecture standpoint and conceptually, this is kind of how we at Esri look at things for utilities. This is your base network information system with the utility network, your connectivity, the network logic, the business rules and so forth, the tracing and schematic capabilities. But really, the utility is running a business, right? So they have issues with emergencies, right? The emergency management, operational the GIS can be used as a system to support all of those processes, and even in the field, whether it's during the construction or also during, when things are as built and for doing inspection and maintenance of the assets. So just, you can take a picture of that if that helps. I'm more than happy to share this with you as well. Thank you. Manoj, please.
Can they hear me? Can you hear me? No. Second one. Consider it as one part of the many components that comprise or combine to make the RGS platform. For the UN, it is a result of significant R&D and collaboration between the global utility and telecommunication communities across the world. Most importantly, it has been created, developed only for the utilities and telecommunications industry. Now let's see what are the 5 key aspects of the UN. So if you see, the first one is it provides you with a comprehensive framework for modeling utility assets and your network data. Second is it allows you to encapsulate or build business rules and business logic to ensure the security, accuracy, and consistency of your geospatial data. Third aspect is that either you can use a file view database or you can go and deploy it into an enterprise view database, this utility network data. Now if you are going for a enterprise view database, you can then expose your network information or the network data in the form of web services, and it can be distributed across the organization in the form of web applications or through your mobile application. Fourth is it enables you to represent the network either in the form of a map or in the form of schematics, which we call it as diagrams. And all these things, they are tightly coupled with other core capabilities such as attribute rules that you can build, contingent values, editor tracking, and branch version. So all in all, the utility network, it is unlocking the capabilities of the RGS platform for network management within your organization. So the community actually, they had the need to go and model complex networks. They wanted to model individual sensors and devices which were actually connected to IoT devices in the real world or in your network. So the UN, it provides you with the ability to do much better visualization and analysis. Apart from that, it is also service-based, hence you can share your network data throughout the organization with anyone, anywhere, anytime. Now we have seen, in the last slide, if you see, we have seen the components of the utility network. Now let's see what are the fundamentals of the utility network. So at the core, as you can see, is the utility network information model. Okay, and you have these 3 components. We'll start with the first one, which is the advanced network modeling. So as part of the advanced network modeling, you can go and configure your domain networks. Now domain network would be electric, water, gas, telecom, district heating. These are the different domains that can be modeled using the UN. Coming to structure networks, these are the structures which hold your network devices. Like it could be a manhole, handhole, poles. So these are going to hold your network assets and the network devices. Then you have terminals. Terminals actually, they control the flow of the resource or the commodity through your network. Apart from that, you have network tiers. So these are nothing but logical grouping of your domain network. if we take the case of electricity, we can say, we can divide it into three. One is your generation, second is your transmission, and third could be distribution. So this is the logical grouping of your domain network. Then you have subnetworks. Subnetworks are nothing but circuits or feeders, feeder management that was there in the geometric network earlier. Asset types and groups, these are very important because this is where you are doing the major and minor classification of the feature classes. In the geometric network, that is how the classification was done. In the utility network, we call it as asset types and asset groups now. So let's come to visualization and analysis. Within the utility network, you have things called as containments. Now, containments are collection of features. For example, you want to see the insides of your substation, a grid station. This can be achieved through containments. Apart from that, you can also, with respect to visualization, you can do tracing. Like these are your logical pathways within your domain network or the network that you're going to implement. Then you also have diagrams. These are symbolic representation of your network data. And earlier we used to call it as schematics. Now the term we use is diagrams. Most importantly, as I mentioned earlier also, the utility network, it is service-based. So any access that is needed within the, needed to see whether you want to edit it, whether you want to visualize it, you want to do any kind of analysis, all those things will be controlled through your ArcGIS enterprise. So that's where your access and roles will be defined. So if you see here, the utility network, it is like together these are going to form the foundation of the modern GIS that stores information, it uncovers business intelligence, and also communicates role-based information to all the stakeholders. So all those three fundamentals are covered within the utility network. So when we talk about advanced network modeling or network modeling with respect to the electric network, we talk about generation, transmission, and distribution. Apart from that, you can also go and model devices such as devices which we call as network controllers, right? These are devices which control the flow of the commodity or flow of the resources within your network. One example I would like to give of a network controller is here, if you see the transformers. Earlier, this kind of configuration was not possible in the geometric network, where you have different terminals, like the high side and the low side. In the geometric network, you just had a line and a point and you connect it, right? But here, you have the option to go and configure how many terminals you have on the higher side and how many terminals you have on the lower side. So this kind of configuration or complex configuration is now possible using the utility network. Now when we talk about the connectivity, earlier each and every connectivity or each and every feature that was there in the geometric network, it needed to be physically connected to each other. We used to call it as coincident geometry. Now we have capabilities such as associations. Now if you see here an example, we are talking about this one is a pole mounted transformer. So if you see, you have your electric distribution line which is separate, you have your pole, and you have the transformer bank. These are all, they are not physically connected or they are not coincident. They are all separately. So this is how this is what the utility network is providing you the capability with. You don't need to have it physically connected at the same point, right? And third is containments. As I was mentioning earlier, containments are nothing but if you want to go and see the insides of complex structures like substations, grid stations. So that is achievable or possible through your containments. And all this can be done for electric, gas, water, telecom, and district heating domains. So the utility network, it also enables your business workflows, which is happening within the organization. Earlier, all the network information we were putting in the maps. Everything was there, whatever you wanted. But now, the maps are getting much more smarter. They are actually directly tied in within your schematics. So your map and schematics you can see side by side, wherein both your map map information and the schematics data. They're tied into the same database, same network information. So any changes that you're making in the map, it gets automatically reflected in your schematics. Earlier you had to go and regenerate the schematics. You don't need to do that anymore. Automatically any changes in your network data in the map will be reflected in the schematics or diagrams that we call nowadays. Component views is similar, like as I was talking about earlier. These are the insides of complex structures, substations, grid stations, or water treatment plants. If you want to go and see the insides, that is achievable by component views. Now, when we talk about advanced analytics, there are devices, network controllers, and other things, and this can also be achieved by subnetworks. Earlier, we used to call it as circuits, if you remember. So those kinds of analytics, you want to do tracing, that is achievable through that. Historical and parallel views. So the utility network also gives you the capability to go and see your network information, like historical data. We have something called as branch versioning, which is being used now. Okay. So with that, each and every edit, each and every insert, delete, okay, update, it is time-stamped. So whenever you want to see what was the network information or the view of the data 1 month back, 1 year back, that can be achieved now. And if you also have planned data, that can also be visualized together. And most importantly, it also supports 3D, as you saw in the one of the slides from Crystal earlier. So ArcGIS utility also enables real-time sharing and collaboration across the organization. Earlier, or even now, most of the heavy lifting or the editing, bulk data upload will still be done with your desktop technology. Now, instead of ArcMap, you are going to use ArcGIS Pro. Okay, it is still the major 80–90% of your work will still be done with ArcGIS Pro. But with this service-based architecture that is supported by the utility network, some of the capabilities from desktop can also be utilized in the web, such as tracing, schematics. Those can be done through web applications. So, you don't require everyone within your organization to know how the ArcGIS Pro works. Give them a web application, they can go and do the tracing and schematics generation. Apart from that, you can also the same network information can also be viewed using mobile applications. So people who are on the field, they can make informed decisions once they are there. And most importantly, any update you are making, whether it is a desktop, web application, or the mobile, any changes, they get reflected immediately, and it can be viewed with any of the devices that are there or being used by anyone. Anyone, anytime, anywhere. So let's talk about the key differentiators between the old technology and the new one. As you can see here, and as I mentioned earlier also, the UN is services-based architecture, right? So using this capability, it is supporting or providing cross-platform support. You can have the same data in desktop, web application, as well as in the mobiles also. Apart from that, you also have the updated network model. So here, not only the network or the feature classes you're going to configure, it is also giving you or allowing you to make more, we call it as connectivity associations, as I mentioned earlier. Then it also has containment. Connectivity is feature class to feature class. Containment is within your substations and grid stations, the assemblies. Then you can also go and configure multiple terminals, which was not possible earlier. The example I gave was for the transformer. Then you can go and expand your tracing framework. Apart from that, you also have built-in support for the network diagrams or the schematics that was called earlier. Most importantly, you are also going to have enhanced editing experience with the help of ArcGIS Pro. So example could be like someone wants to place a similar kind of feature multiple times. Now he doesn't have to go and write the attributes every time he's placing the feature. The capability of templates are there now. And we also have something called as assemblies, which are collection of features. Same example, you don't want to go and create the substation multiple times. You create it once as an assembly and then multiple times, like you just take the assembly and place it. You don't need to create each and every feature class within the substation, which takes time, right? And that is also supported by the attribute rule framework, where once you have these attribute rules in place, it is kind of a QA/QC check for you, right? So that framework has also been added, and most importantly, it leverages the updated transactional model, where you can also go and see whatever historical changes are happening or you want to track them, and this is more flexible and less overheads. Okay. So this is the last slide from my end. The utility network, it actually aligns with the industry vision and requirements. As you can see, there are 5 areas here. First is modernization. A lot of the utility companies or community, they want to modernize their network. They want to integrate location with smart networks. They want to see what is actually happening in the field in real time. So that is possible now using the utility network. And if you want to see the modernization, that is also achievable by the real world data models, because utility network gives you the capability to model what is actually in the field, which was not possible with the geometric network earlier. Since it is service based, it is interoperable, and you can spatially enable any of the business systems within your organization to interact with the utility network. That's how it is helping you with the industry vision. Also, with your modernization and design, you're in a better position to manage your assets that are on the field by applying the best practices and industry standards. And most importantly, all the information that is there out in the field, you can get the inputs, or how do we call it? The real-time operational data can be brought within the utility network or the utility network data model. So this is from my end. I will hand over to George. He will be showing you the utility network demo. Thank you.
So next we'll go. It's duplicate here. Isn't it duplicate? So next we're going to show and explain the utility network. We're going to go through the main features: data modeling, editing and data integrity, tracing, and diagrams. So let's start with the data model. A utility network is a data set, just like the network, a geometric network was a utility, was a data set. In that utility network, we have multiple domains. What is a domain? A domain is a set of equipments that moves a commodity. It can be electric, water, gas, telco. A utility network can contain multiple domain networks. Okay, so if I have water, electricity, telco, I can put them all in the same utility network. A structured network is a set of equipments that holds the equipments of the domain network. For example, a pole can hold a pole-mounted transformer. The pole holds the transformer, but there's no electricity passing through the pole. And then all the domain networks, they share the same structure network, because a pole can hold telco equipment and electric equipment. So I can have multiple domain networks, one structure network. A domain network is divided into tiers. My friend Manoj said an electric network can be divided into generation, transmission, and distribution. Here I have an electric distribution network. Still, I divide it into 2 tiers. Let's see here, go to the configuration. I divide it into 2 tiers. and those are the medium voltage and the low voltage. Okay, in each domain network is divided to 5 feature classes and 2 tables. The main feature classes are junction, device, junction like a riser, a tap, device like a circuit breaker, a fuse. The difference between those two is that the device can cut the flow. It has a state. So it can either cut it or redirect it. The third feature class is assembly, which is an assembly of equipment like a switch bank. Next, I have 2 line feature classes. The first one is low voltage, cable voltage, bus bars, all the line equipment. And the final feature is the subnet line, which is like each subnetwork has a representative line, and it helps me to manage the subnetworks. Those are the 5 feature classes. The tables are junction object and edge object. In a geometric network, we didn't used to have non-spatial object, but let's say I have a surface point connected to so many meters in the same meter room. So I have different meters in one location, and I cannot just draw them on top of each other. I'll have overlapping junctions. So to avoid this, I will have the service point connected to objects meters. So the meters will be just objects, non-spatial objects. Okay. So whoever worked with geometric network knows that in any geometric network for utilities, we have like at least 60, 70, 80 features, and it can go into hundreds of features. How can I fit them into 5 feature classes? I use the concept of asset group and asset types. Asset group is simply a subtype. You use subtypes, right? So asset groups are subtypes. Connection point, riser, tap, those are asset groups. Fuse as well, circuit breaker. Okay, let's go. Let's go, for example, to the line here. So I have bus bar, low voltage cable, medium voltage. Those are the asset groups. And each one is divided into asset types. For example, for low voltage, I have the underground and overhead. For the medium voltage cable, I have the single phase, 2 phase, 3 phase, and overhead and underground. The structure domain, it has 3 features and 2 tables as well. 3 feature classes and 2 tables. I have the junction structure like a pole, the line structure like a duct, and a boundary structure like a substation boundary. And same for the non-spatial object, I have 2 tables for point and line features. Okay, done with the data model, let's start the editing. This is my network. It's a distribution electric network, as we said, divided into medium voltage and low voltage, and it has 2 sub-networks. Okay, I wanna provide electricity to those 2 locations. Before start editing, one feature that we didn't have in the geometric network is feature templates. So here for each feature, I have a template. In this template, I can decide the editing tools. I can set my default attributes. And then each time I add this service, all those default values will be populated automatically. So I will add the service points. And now I need to connect the low voltage cable to the transformer. This is the nearest, here this is the nearest transformer. So I'll connect the local voltage cable to it. I will use the radial. So first I was able to snap and I was able to draw those lines. Why? Because it's all set in my connectivity rules. In utility network, like in the geometric network, we have to configure connectivity rules. And connectivity rules, for example, here we have junction edge. We connected a low voltage cable to the transformer. And we can see here a junction device, a transformer, an overhead transformer can be connected to a low voltage overhead. And this is the configuration that we have. But in the geometric network, our rules used to be a transformer can be connected to a medium voltage and a low voltage cable, both. Here it's different. We have the concept of terminals. So a transformer has two terminals, the high and the low terminals. And the high voltage, I'm setting the connectivity rules on the terminal level. So the high terminal can be connected to a medium voltage cable. That's what we see here, a transformer. High terminal can be connected to a medium voltage, but the low terminal of the transformer can be connected to the low voltage. And here we see the terminal configuration. A transformer has two terminals, high and low. Next, we see here the purple rectangles. Simply in utility network, when we add any feature or edit any feature, it doesn't go automatically into our topology in our network topology. We need to validate, and when we validate the rules, like when we click on validate, all the rules will be checked, connectivity rules, topology rules, and I will get errors. Here, we can see the type of polygons that I will get. I have here dirty areas, which means I have edits that they are not in my network topology yet. I go to utility network. I can validate all the extent or the current extent. It's a small network, so I'm gonna validate the whole extent, and done. I have no errors anymore. How can I make sure those are connected? I will run a trace. So I will add a starting point, and I will run a connected trace. This is my starting point. Okay. I want to include structures in my trace, and I will run it. If I include containers in my trace and I run it again, I will see this will be selected as well. Okay. Those two are selected in my trace. I'm able to trace them, which means they are already in my network topology. Otherwise, I wouldn't be able to trace them. But let's dig deeper here. I was able to reach the service points, though I have disconnected equipments here. Yeah, they are not fully connected. So how this happened? This is the concept of associations that Manoj talked about. Now, if I have a pole, I have a pole-mounted transformer, I have the fuse, So how can I can make all this configuration? Usually we used to use low voltage cable. We used to draw the pole just next to the network, not connected to it. And if we want to connect it, we would use some attributes just to create the link. No more. It's totally different here. We have different connectivity type here. For example, here this fuse, it has two connectivity to transformer and to the connection point. And it has one attachment to this pole. If I click on the pole will have 3 attachments. It's attached to the transformer, to the fuse, and to the connection point. And now if I want to run a trace and check, include structure in my trace, I will see that the pole will be selected. If I will uncheck it, the pole will not be selected. I can decide what do I want in my trace. Okay, next is diagrams. Well, the first time I did a utility project 15 years ago, my friends are sitting there. We used to digitize the geometric network alone and then re-digitize the single line diagram. And we had 2 separate data sets. And that was like, I had this question, why do we need to do that? Like, we need to maintain 2 databases and we need to keep them in sync. Well, no more. I'm gonna select the whole network. I will go to diagrams. Okay, I didn't save my... We need to save our edits first. I can do a certain selection and automatically generate my single line diagram, my diagram, and put it side by side with my network. Okay, if I want to change the layout of my diagrams, I have multiple layouts. So I'll go the top to bottom. You can pick any layout. And here I still have the 2 sub-networks, and this is my container. I will run a downstream trace. I will, okay, sorry. Let's go to the starting points. I remove this. I will add this circuit breaker as my starting point, and I'm gonna do a downstream trace to trace my whole subnetwork. One point to pay attention, the importance of terminals. I cannot start my trace if I wanna do a downstream trace from the source terminal. I will get an error when I do the trace. I need to start it from the load, which is the low. Yeah, because I'm doing a downstream trace. And then I will do a downstream trace. It's my electric distribution. It started at the medium voltage, but it will end at the low voltage. I want to include structures and containers in my trace, and I will run it. Well, honestly, better not to include containers. Yeah, and then this is my trace. If I want to reflect it in my diagram, apply to diagrams, and I can see the same downstream trace is just side by side in my diagram. This subnetwork is not selected, this one is. And I have them both side by side. The last point I want to show is the internal components. And for that, I will move into a transmission network because we have more complex internal components. This is a substation. Okay, diagrams, new. I have different template of diagrams, so I'll go to the expand container. And now I have the internals of my substation side by side, the geometric equipment and the single line diagram. So with this we saw the data model, we did editing, validation, data integrity, and then tracing and diagrams. Now we have 5 minutes for questions. You mean you have, okay, the question is, we have the single line diagram. You mean if you do a selection, can you move it back to the, yes, because we have here, when we go to utility network, we have apply in diagrams. So if we do something in the utility network, we apply it in the diagram. But if we do something in the diagram and we want to apply it in the maps, we use this button to apply it in the map. So we have those two buttons to move back and forth. Yeah. Ah, you mean redraw? You don't draw in the single line diagram. Yes, you reflected in the maps. As you mean because when you edit the single line diagram, in the single line diagram you don't have the geometry. We don't do editing there. We have, you know, you cannot put it here or there. It usually started in the, yeah, especially with geometry, putting the feature. You cannot do it in the single line diagram. Any other question? Yeah. Well, usually you can represent in both, but it's much easier to represent, for example, internal components in the utility network. Yeah, you can play it and you can do it in the geometric network, having all those, each and every internal components. But it's much harder to do it, and it's much harder to maintain it and manage it. It's much easier in the utility network with all those terminals and like all this configuration.
That's good. Yeah. So that means utility network is providing a better option for representing the assets.
Yes.
Yeah. More assets rather.
Yeah, and you have multiple concepts of associations, attachments, and terminals. You don't have all this in a geometric network.
Right. Thank you.
Yeah, one last question because I have to jump to my second session. And if anyone is interested in environmental, we're in room 2. Can you take this question, Manoj?
I just want to ask about the ducts.
Ducts,
the conduits, how it will be reflected and migrated to the GIS.
See, I believe earlier the way it was done in RKFM, still now it doesn't support the same way of representation yet. There will be updates coming up where you will be like the butterfly view and all those things, right? As of today, that's not yet available. But coming versions, yes, that will be supported. I cannot say when, but it will happen. Right? Thank you. The gentleman had a question.
Thank you, sir, for this wonderful presentation regarding utility network. Sir, I have one question regarding how we can utilize schematic diagram in operation department to help them to operate feeder shutdown.
Help feeder shutdown. So, now for example, if you are having any kind of an outage and other things, and you want to isolate, right, the network. Presently, what you're doing the tracing and other things, right? But you don't know from which particular terminal in that particular device you are coming from, right? Whether it is on the low side, high side, even if there are multiple terminals on either side, which one is true? This is possible now with the UL. That is not like, everything
Bismillah.
Any kind of validation.
Test 1. Bismillah. Bismillah ar-Rahman ar-Rahim. Test 1. Test. Check 1.
No, he was trying to show you an example. Because he has already set those rules previously. So you can do those checks.
تمام. بسم الله. شوف. بسم الله. لازم يكون فيه. كيف؟ عادي بعليه بس النويز. بسم الله. بسم الله. بس النويز ضاعت. بسم الله. تيست 1. تيست تشيك 1. بسم الله. تشيك 1. بسم الله. تشيك 1. بسم الله. بسم الله الرحمن الرحيم. ما فيش نويز. بسم الله. بسم الله الرحمن الرحيم. تيست 1. تيست تشيك 1. تشيك 1. بسم الله. بسم الله. بسم الله الرحمن الرحيم. تيست 1. تشيك 1. تشيك 1. على الكاميرا ايش فيه؟ ما نقدر على الكاميرا اعطيك اوت. ما اقدر اعطيك اوت على الكاميرا.
بسم الله بسم الله وريني كده بسم الله الو الو الو
تست. بسم الله الررحمن الرحيم. تيست 1. اوكي. تشيك 1. بسم الله. اوكي.
اوكي
اول ما تبدا تتكلم تقدر الحين الناس سامعينك.
اوكي
قبل ما تبدا لو انت تبغى تطفي كذا.
Hello, everyone. Can everyone hear me? Great. So, welcome everyone to this session that is primarily focused on GIS and sustainable architecture and urban design. This session is a bit focused on the bigger picture of AEC within GIS, within Esri, the Esri environment. And just to have a little bit of a focus on the next two sessions that are to happen in this room. The two sessions kind of fall under the umbrella of what we call AEC, or architecture, engineering, and construction practice within Esri. And we are, the first session here would be more focused on sustainable architecture and planning, urban planning within cities, within new giga projects and so forth. The second session, which will happen an hour later, will be run by my colleague Sham Ghaffar from Esri, Saudi Arabia, and will be focused more on construction management and everything to do with design and engineering. So, looking at the context here, the context really of our overall strategy within Esri is focused on questions of why do we, where do we want to have evacuation plans for cities, in the planning side of things. How do we connect to all these sensors and existing systems, even if that's in an initial planning phase of things? What kind of systems do we need to install? Where do we install them? And how do we track those specific readings and streams of data that come into the system? And why do we want to track them? How are they going to be useful in the future in our life cycle of the assets that we're installing? Other things are such as traffic impact and designing places, designing cities, designing towns and neighborhoods where traffic is minimized in certain areas. Transportation links are made easy and available for the community that is to live in this city to commute from one point to the other. Also, things such as the environmental elements and the impact of my design, of my plan, and seeing things such as our green spaces. How do we design them? How do we plan them? How do we locate them in the right places to have the most impactful decarbonization of the city footprint? So those are all questions that really provide the questions and collaborating with across different departments, not just so the GIS, bridging the gaps between the design part, the planning part, and the construction and field operation side of things, kind of helps facilitate and basically hone down on this specific goal of providing the context to all the projects as it moves on. Now, the idea is a slide that I like using a lot, which is, what is the bigger picture? When we design, when we plan cities, what is the bigger picture that we have? And the idea is creating a digital twin, digital twin, which is a copy of all the assets that have not just one assets, like you might think, for example, in utilities or in the engineering side of things. It's a bigger picture of that. You have all your assets, all your roads, all your transportation networks, utilities. All those in one specific snapshot in a digital format that is integrated with all those different systems, all the kind of sensors, all the other ERP systems, the CRM systems, all the other things that surround the GIS in a geographical format that connects those environments with each other, but also makes helps make that city a smarter city, so achieve all the bigger goals. So goals such as my sustainability goals, my carbon footprint, my emissions, other things such as livability of cities, things like the safety and increasing the safety, or designing a place or planning a place where the citizens of that place feel safer in different times of the day, that are more livable. They can reach point A to B easily in a very coherent way. Now, the idea here is that digital twin serves different sides of the operation. So one of them is, which is what we're talking about today, is the kind of the planning, design, and construction side of things. And that's very much focused on the initial bit. So when we're building those parts of the city, how we interact with that twin in order to enhance the kind of design, the plan side of things. And the monitoring aspects. So aspects to do with, again, those sensors and how they come into the picture, how do we integrate that into the bigger GIS. But things such as field mobility as well, on tracking my resources, my engineers, my people who are helping building the site. So the maintenance side of things, but not just build the building aspect, but also once things are built, how do we maintain them? How do we allocate or send the right people to fix the right things or to address or to survey the assets and kind of maintain records, update records of those systems? The enhancement and the use of analytics or geo-analytics elements, so leveraging things such as cloud computing for enhanced processing, big data repositories to kind of enhance and work with data in a fast and process data faster, but also using AI, or artificial intelligence, or as we call it, geo-AI. A couple of other sessions are happening in parallel as well in adjacent rooms, just focused on the bit to do with AI and leveraging AI tools within the geospatial context. And then extracting those patterns, understanding where my assets going to fail, again, the life cycle, when likely they're probably going to need maintenance, where do I, based on your planning, based on your soil, based on other elements, how do you kind of, again, analyze the likelihood of things to happen, but also reading, using big data, reading the patterns and the things that have happened in the past, and trying to, again, create those correlations, this autocorrelations between space and time of certain assets, and seeing what do things happen in certain areas that are similar to other patterns and other things that happen in other parts of the city. But then there's the bit to do with communication. So once I have this data and I have applications, I keep on developing all those kind of nice, easy to use by anyone type of applications in GIS. How do I design those to be integrated to other systems? How do we communicate that to the wider society, to my citizens, to other government organizations? Help create that ecosystem of collaboration between different departments, and that's another part of focus of how we design the software. And then finally, the collaboration between different departments. I think that's a bit that we probably all experience a big challenge in trying to bring different departments in one organization to work with each other, to collaborate, exchange data in a way that kind of is standardized. And by standardized, I mean that we use open standards. I use open data standards, ISO or OGC, Open Geospatial Consortium standards that kind of regulate that exchange of information, exchange of data between different government departments or different departments that of that digital twin, that or collaborate and work on that digital twin. But then the underlying technologies are pretty vast, and there's many tools across the ecosystem that kind of feed into these areas. So you can see we started off with having ArcGIS desktop, so ArcMap in the past, which we've all migrated now, almost everyone, to ArcGIS Pro, and this migration is still happening. That's the desktop application down in the bottom right. But in ArcGIS Enterprise, it kind of helps build up all the data sets around an organization, enhance and enable that collaboration between different departments. But then also ArcGIS Online and Living Atlas, which are big repositories of data that is available. Some of it is authoritative data that is released by government organizations that have authority to kind of collaborate that data into the public domain, but also ArcGIS Online, where users contribute data sets that they've been using, been working on, have developed and altered and put online for others to use. Now that kind of base of core things that we have in the platform was good for GIS in the past. Now we wanted to build specialized apps to kind of help all this bigger life cycle, and this is where we've kind of placed different products, different specific extensions, for example, and specialized products that help every one of those areas to work with different tools, just address their general feeds, business units needs specifically. Now, focusing on our vision as Esri, as a company within the AEC focus, we focus on a few points. So we focus on helping AECs to leverage, again, the value of location analysis. So we know that lots of organizations, lots of AEC organizations, that being either AEC companies or giga projects that are building their own thing and working with subcontractors in either case to collaborate and build that infrastructure. How do we bring all these these organizations together? How do we foster collaboration? How do we also enable projects to be executed sustainably? So we calculate things like ESG metrics that help the planning and the architectural side of things happen in a very sustainable way. But also, how do we make sure that we can not just use GIS to build things, but also how do we create again new digital revenue streams? How do we make this convert this data as we go into data that we could again generate revenue out of? That revenue being either monetary revenue or could be value revenue across the different departments that make sure that other organizations, other government departments leverage that data, do stuff with it, and it just doesn't die off there. But also, every organization has some form of GIS. Some have an elaborate big ecosystem of GIS. Others have a smaller system. And the idea here is to maximize the investment of that technology. You've already invested in that technology. You've invested not just money. It's invested efforts, invested architecture, invested hours of thinking about this technology. Now let's maximize the use of it. Let's make sure that everyone benefits from it, even the very remote parts of the organization, such as financial departments and procurement and others that can use the power of location because the data is already on that platform. So that's our vision, to convert or democratize the use of GIS or geospatial technologies within AECs and how we go around about it. Now, our focus as well, and that's a little bit of an intro into our focus as a company. So our focus is into those four main streams. So first part is the environmental consulting side of things, so helping achieve the sustainability metrics in your planning, in your design, again in the construction phase and in running as well a city. But the AEC focus, as a sector focus, we have focus on the environmental aspect and understanding those studies and in environmental impact analysis of projects while they're being constructed, but also on the future design of them and the long-term carbon footprint that a project or a city would have in the future once it's in operation. Second stream is basically the architectural side of things and urban design. So focusing again on geodesign, landscape, and the actual design of buildings and how they look like and the impact of that on the bigger environment within, again, coming back to the word of context. The third bit is, or the third pillar is engineering side of things, and again that's focused again on the asset management aspect, on the infrastructure and how do we develop it, people in the field, and basically again how do you design a phased approach where project management kicks into place, which moves us into the fourth pillar and into the construction management aspect, and basically talking about not just managing people in the field, engineers on the field, people going building things and tracking them, seeing where they are and doing stuff, interacting with them and allocating them to the right work, but also the project handover, so helping once things are constructed, built, and the as-builts and all the plans that have been delivered also are handed over to whoever is going to run that development in the future. So breaking those down into each one of them, just to lay the context here. In environmental consulting, there are many challenges. So challenges such as you have siloed data, you have duplication of data across the whole life cycle. Very common problem. We all have this problem. We have the utilities guys have their own infrastructure. It's a big infrastructure. You have other lots of plans and they designs for the plans and where they're going to extend their network. You get the engineering guys building their own things, their master plans, and you get other departments, the transportation guys, again, planning, doing the transportation planning element of things. But then you want to bring everyone into that kind of metric, those numbers. In the end of the day, it's all data-driven. So we want to come down to numbers and make sure that number in the end of that specific element that will affect the environment is minimized if I have this plan from all those different departments that looks in that kind of way, and have scenarios. And that's the idea of again of the consulting side of things. The GIS plays a very big role in bringing those departments together. Also helps kind of grasp the complexities of this process. Also making predictions and offering again real solutions to those kind of plans that people come up with, but also making sure that not just this, the collaboration between the shareholders, the stakeholders in this environment is kind of work, but also making sure that in the end you have this result that is easily communicated to people. Again, decision makers in the end that decide on plans in the end, they can easily say, well, it's easy for us to kind of decide because our top priority here as Project X, for example, is to minimize our carbon footprint and not and minimize our ESG output, and therefore you get a decision could be easily made in this context. Now, the second part is our second pillar that we focus on, or how again we cater and focus our sector GIS solutions and tools that we create is architecture and urban design. So on the design side of things, basically usually in organizations, scenario analysis is a big thing when organizations kind of create those kind of big plans. Again, as I said, like they need to understand not just the environmental elements, but also the impact of that on transportation links, on the maintenance of transportation links and roads and road furniture. It also, the design has to bear in mind the other metrics that you set us and you prioritize as you wish and you rank in priority as you wish to focus on things that achieve certain goals. Those other goals could be, again, as in the utility side, for example, minimizing the amount of pipeline lane that you're going to do based on that architecture, based on that plan, and so forth. So to minimize that and to better distribute and allocate schools that cover the big proportion of the city that you're trying to cover. And so basically the site selection, if you come from a GIS world, site selection is kind of one of the basic functions that GIS helps you deliver. Where do I locate a new school? Where do I locate a new hospital? And all the kind of services side of things. So within the plan, GIS provides you with all those kind of sides of things to kind of help answer that question, but also, again, which is a big focus of how we mature our technology and try to focus on building it better, is again making it non-GIS-y. So while GIS is very big, half of the room at least kind of comes from a GIS background, the other half doesn't. We want to make it easier to the other half to understand the context of GIS and understand the output. In the end of the day, they don't care how technically things are done. All they care about is what is the value that I get out of those tools. And again, the client here in this respect is everyone around the organization. It's not just one department that kind of leverages that. It's everyone. It addresses the needs of every single department, and that's a very important point when we focus on architecture and urban design. Another element is, or a third pillar, which is engineering and consulting. And again, GIS engineers and consultants and external parties, so other contractors that work with, they need to collaborate. That's a major challenge that every one of you probably sees on the ground. But other things are basically the demands and things that are kind of to do with digital delivery. So RFPs come out because lots of you want a digital delivery in certain formats according to certain standards that kind of fit within your existing infrastructure. And that's the whole idea of well, how do we make this easier, not just for you, but also for your service providers or your contractors that work with you? How do we make sure that they know what to deliver in what format, in what is the completeness of all the different attributes that they need to be submitting the data in, whether that being kind of a GIS delivery or a submission or a BIM submission or other submissions that fits into the bigger ecosystem. And this part is very important to understand, and as long as it's made clear for you in the bigger picture, you can very much understand the context of your decision-making process on when it comes to awarding projects to contractors, and vice versa for contractors. As long as you understand that this is the reason why my client wants me to submit things in certain formats or in certain ways. That's because they're going to use it in certain elements. That the easier it makes your job to go moving forward, and the easier it makes you kind of preparing your submissions and things to submit easier in an easier manner. Now the fourth part is more on the field side of things, so the construction management aspect. So all of the challenges that we have on construction management are basically project management stuff. So things like well, I need to manage my cost, the schedule, so the time, things to do with safety, elements to do with safety, compliance, and things of that sort. Challenges are, again, all these kind of risk factors that I have, how to translate into money and time, and impact on quality as well. But also, there's another challenge with, well, data collection. How do I kind of collect the data constantly to maintain my my project data as it goes and it evolves? Also, other things are related to problems of time emergency. I have an emergency now in the field. Something hasn't been delivered because of supply chain problem. How does that impact my project plan? How is it going to move milestones because of something that is very geographical, something that is meant to kind of fit into some part of the project, and what's the impact on the bigger kind of project timeline? So all these are things that we've been focusing again on the project delivery side of things. Again, tracking people on apps, tracking my employees and people that are contractors on apps to kind of understand what they're doing, where they're doing it, and how they're doing it. If they enter into areas where again they're non-compliant, not authorized to kind of move into, or not, so kind of the geofencing side of things, raising flags when the flags need to be risen, tracking, again, reality capture side of things, a big thing that lots of companies use, tracking using drone imagery or satellite imagery, constantly tracking your project site, understanding things as they evolve, and that's all a big focus of ours. Now, again, in this session, we're focusing more, like this second half of the session, we're going to focus more on the sustainability and architecture and planning side of things. Whereas the second session that, again, my colleague Hisham is going to run is going to be focused more on the engineering and construction management side of things. So, moving into sustainable architecture and urban design. So, basically, the idea here is, well, I'm now in a planning phase. I kind of went out there, try to see how a site looks like, the topography of it, and I have certain rules and things that have been put upon me, so regulations that I have. Now I want to tie those rules into land registration, into things how we're going to deliver things in the future, but also how do I plan my my city based on those regulations and those elements that I have. What are my priorities? I want to set them out straight. So all these kind of goals kind of help me ask either my planning team or my subcontractors that are kind of in charge of planning to come up with some different planning scenarios, give me different scenarios, and makes my decision making way easier. Now the idea is GIS helps in this ecosystem in different ways. So GIS can support things like decision making and planning around urban design. What it does basically is it provides context and enables users to again unpack existing patterns with basic and advanced analytics that come out of the field. GIS also helps with GIS designers and planners, so they can do things such as access and compare different results and differences and differences between different scenarios. It also helps GIS to kind of be leveraged in a digital engagement through different public workshops that you can run that kind of bring that community together, all the stakeholders together, but also enable things like community outreach, so enable you as well to kind of talk to the citizens of the city where you're rezoning things or replanning things, or new cities where potentially you have shareholders, stakeholders that are going to be involved in building hotels in the land that you're planning, or building hospitals, or people that are actually going to use and live in this environment. So the idea here is basically GIS is in essence an urban design and planning workflow for all those elements. So the idea here is having 4 key areas of this workflow. So first, as you can see on the screen, it kind of enables you to do a quick creation of 3D context of the area that you're trying to plan and design, but also enables you to move on afterwards and have circulate that design across different stakeholders, and it helps you as well kind of subdividing those kind of building blocks in order to come up with different adopt different zoning plans and schematic designs in order to adhere to the rules and things that you have in place. But third step as well is to kind of make that scenario comparison between different scenarios and trying to see, well, this scenario achieves 90% of my goals, and that's based on data, because based on the GIS, the road data, the utilities GIS data, the planning and engineering the GIS data. So it kind of brings all that together, extracts the numbers out of them, and then gives you a metric, a quantifiable metric, which is the last bit, and quantifiable metric to kind of basically tell stakeholders in the end, well, you have those 3 different scenarios for planning the city. You choose, but these are the numbers. Numbers speak for themselves. If you prioritize this over this, or if you want to change your priorities, this is what the output looks like. And this is the idea and the goal of how GIS would look like. And again, the tools to achieve this, they're within the ecosystem that we've got, within all those kind of different players or the kind of users that use this information between the mapping engineering, the system administrators, the surveying teams, and they go kind of do the pre-survey, the surveys as you go, and then keep up with the site as it develops. The urban designers and planners, again, external partners and internal partners that kind of are part of this ecosystem. Those are different layers of users that require different inputs, but they also want to have a certain ecosystem that kind of enables and helps them achieve their job or do their job better. So the application ecosystem that we've built to kind of address those parts are, as you can see on the screen, it's the second bit, and some of them are business applications, some of them are internal and external engagement kind of tools to enable kind of talk to other stakeholders through applications, so communicate my GIS to others. So the business applications include ArcGIS Hub, which is a system kind of hosts data, enables the kind of collaboration, sharing of data, but not just data as in maps, but also apps and things that I develop. But then ArcGIS Urban that helps on the urban planning side of things, and ArcGIS City Engine, there is another tool that enables you to do the design based on a GIS input. Again, the communication of that happens through different elements, and story maps is a good one, which lots of you, I think, use story maps and see, again, start using, again, like we saw yesterday on stage. You kind of throw away PowerPoints, not all the time, but sometimes when you have geographical aspects that you want to show, story maps are really ideal to do that, because if you already have the data, it's easy to kind of show things and present your outputs based on it. But then you have the foundational elements of the system, like I mentioned, and all the different types of integrations, including integrations with bringing in open data and harnessing the kind of all the standardization side of things, and external systems, but also other systems that kind of adopt other standards, and again, integrations with other systems like SAP, Autodesk, Oracle, and others are big in different parts of the ecosystem, and we recognize that. Now, the idea here in the planning side of things is ArcGIS Urban kind of helps you very much on the planning side of things. Again, comparing scenarios with each other. But then the urban design kind of City Engine kind of focuses very much on once I have the plan, so how they design this in a way that adheres again to the goals that I kind of highlighted in my list of priorities. But also the visualization side of things. So what about people who, or stakeholders who don't really understand the GIS world and the design side of things or the planning side of things? You just want to understand how is this going to look like, how am I going to sell it, and how am I going to facilitate maintenance of it, and so on. And this is when things like gaming engines kind of come in, which lots of integrations are facilitated and made easier with using things like Unreal Engine to integrate with this type of data. Now, I'm going to move a little bit quicker into things such as some examples that we kind of seen that kind of really stood out over the years, and just kind of focusing a little bit on environmental analysis, and with the big GIS environment, basically the shift to digital environment and environmental impact analysis has been quite big. Calculating things such as, again, pollution, the amount of heat, and area and emissions that come out of certain developments. How does that look like? How do we quantify it? But also, how do we minimize it by increasing the green spaces in my plan, in my design as well? Again, there's so many ways to kind of calculate as I design. I calculate my EIAs, my environmental impact metrics, and as I plan, I also that metric that number changes based on, I mean, again, the amount of green spaces that I put in, the roads that I minimize, the change in design as it goes, and again, the use of things like story maps, for example, and again, WebGIS is very fundamental and very is a cornerstone basically of how you communicate that to the wider community and the wider people, stakeholders that you discuss these things with. But then this is other work by, again, one of our partners, Tetra Tech. So they kind of have very much focused on the climate change and resilience side of things. So while at the design stage of the city, or redesign and rezoning of cities, they started looking at creating a common operating picture for again, for authorities that work with the disaster response to be faster, to reach the right places in the right times, and that's achieved using things like data integration, integrating all the siloed data sets and systems that have been not talking to each other into one picture, and that helps very much the replanning and rezoning side of certain cities. But then another work here is on rail and forestry sectors, and it's basically again, one of our distributors, so Esri UK, have been working very much to calculate the digital environment impact assessments of rail tracks, and whether they can pass the intrusion of project, if you've heard of the HS2 project in the UK, the impact of it on the forestry side of things, and bringing in other stakeholders such as the Forestry Commission in the UK and others to give them the assessment of the planning of those rail tracks within across the country, and how is that going to impact, again, not just pollution of sound, but pollution of the emissions that come out of it, the kind of the metal that kind of gets that kind of comes out of this environment into the wildlife, and the impact of that using again GIS. But then work with, such as work from Jacobs, where they kind of, again, do this environmental assessments based on again, a huge GIS data sets that they have, that they try to bring together. And the idea here is rethinking the idea of, which just pure GIS and bring in again future plans, future possible plans of transportation links across the certain geographies, and that's within cities. Seeing if I increase my car ridership within a city based on that rezoning formula that I have by 10% on certain roads, how's that going to impact again my noise and vibration kind of numbers? Can the geology really affect the amount of maintenance works that I will do to those roads if I increase my transportation and my congestion on those specific roads, the specific main roads around this is specifically around London in the UK. How's that going to affect my maintenance work and the amount of workforce that I need to bring into the field? So moving again into planning and architecture, and a couple of case studies here. So there's work here that has been done in Sweden by one of our partners, Sweco, that kind of looks very much on parametric massing models. So it's pure in the architecture, in the planning side of things, trying to manage the design iterations and keep track of them, version them in the right ways, but also calculate summaries of GFAs or gross floor areas based on certain plans, and try to calculate as you go, and making sure that you're providing enough space, livable space, in Plan A or Plan B or Plan C for people to live in within certain transportation analysis zones or TAZs. So then certain TAZs, you calculate the number of square feet or square meters that people are going to be utilizing for living space within that Plan A, and versus Plan B versus Plan C, and so forth. Interesting work. But then another work is done here for the regional housing needs assessment by, again, one of our partners, House Levine, who are one of our gold partners. What they do is they're very much focused on ArcGIS Urban as a tool to kind of help on planning and again making sure that best practices of the planning side of things are implemented in the way their clients plan. So they provide the calculations, the building blocks of the GIS that goes into as an input into ArcGIS Urban in order to achieve those goals, in order to build this provide the right housing developments for the city in the right places and the right place. Provide the use the right visual elements for those organizations to kind of make the right decisions on the planning element. But then again, on sustainable planning as well, looking very much again this is specifically in Vienna in Austria, and this is coordinating so many projects that come from different places. Again, looking at GFA in different parts of the projects and seeing the impact of their replanning and the impact of that again on the livable space in different parts of the country on different projects, but understanding also supporting analysis such as green spaces ratio and carbon emissions, and again providing an overall picture and the documentation that goes into each one of those projects and harmonizing how those documents are being submitted and maintained to kind of enable that sustainable planning element. Another project that is done by one of our partners, Fosters and Partners, who has worked on a South Sabah Al Ahmad master plan, which is again a city in the middle of the desert. Again, sounds familiar to some of you. And again, the plan here is basically creating not just a city center, but that's in Kuwait, sorry, but that's not just creating a city center, is creating the ecosystem and transportation links for the citizens that are going to live in this project to move from across the city to go shopping, go to hospitals, schools, and do school run in the morning, do the afternoon chores, go to work, come back in an environment that enables, and in a design, sorry, that enables maximum shaded areas because of the heat, obviously in Kuwait, just like we have in Saudi Arabia in some seasons. not today, not this season. But enable the shade to maximize the amount of shaded walkways, to maximize as well the amount of, or distribute properly the green spaces across the city in a GIS manner, and also minimize the amount of, again, building of roads and building of utilities infrastructure in order to supply and feed into the cities in a very optimal way, an environmental conscious way as well. So it's not just looking at the environmental elements and sustainability, not just on the planning, design, and construction side of things, but also when you come to run the city. Another example and that I want to highlight is from the Red Sea Global, basically where they've developed a GIS hub. Great hub that kind of enables lots of things. So enables kind of an exploring side of things. So as a Red Sea Global employee, you can go in, explore data on your GIS portal. Some of you who kind of have built their portal across organizations, you can test data. Sorry, you can look around data, explore data, find the data that is most relevant to you. Also have scene viewers, so 3D viewers that kind of enable you to visualize 3D data that you have on the platform, very easy over the web internally within the Red Sea Global, but also create story maps because the data is already there. Create those story maps and have tools and templates that kind of enable you directly to create those story maps to address whatever sector or department you work in, to report on some certain issue or report on developments in planning and aspects that you've been working on. But also the feeds into three parts, so the environmental sensitivity. So basically, they have survey 1 to 3 kind of deployed in the field, calculating their environmental impact analysis assessment, as they go, creating those dashboards that are easily they're deployable, but everyone has access to across the organization. There's a huge amount of transparency on the impact of those designs and those plans. Another thing is the design and construction side of things. So integration between BIM and GIS, a massive thing to kind of to be able to visualize those designs in the field, but also the planning and collaboration and decision making, kind of bringing everyone, focusing on master plan versioning and a big issue, but also field maps and apps that you look at. So one last thing, and I'm going to open it again to a bit of an open discussion and amongst everyone. And I've got specifically as well Roshan, Noah from NEOM, and others are running the room as well to kind of address a little bit of some discussion. And maybe this is a good leeway to kind of start those discussions. But again, Noah has been working on the NO Hub that kind of tries to enable different departments to enter and different users to work and interact with GIS elements and the GIS infrastructure you've got in the water department, and also you've got 700 plus users apparently that kind of use this hub. And maybe to open it and move it aside a little bit on an open discussion. Does this benefit really? How do you see this benefiting a lot of the users that you've got? And is it being adopted by the bigger and kind of wider community within NOAA?
Hi, Adil. Yeah. Thanks for this opportunity. My name is Nina McVinish. I'm from NOAA Water. I'm the GIS manager. So within NOAA, we built the GIS hub just over 2 years ago. We needed to build this because, as Adil mentioned, we have 700 plus users within our teams. We built the water hub. We do have an energy and hydrogen one as well. And this was to integrate our users and our stakeholders so that they'd have greater visibility in our GIS data. As you can see on the screen here, we've got our GIS Explorer. So we've got an integrated map that contains our water assets, our hydrogen, and also our energy assets. Thanks, Adil.
Yeah,
thank you.
Thanks. And maybe as well, Nina, there's another part of your business in terms of the assets and the life cycle of the assets and how you kind of maintain them.
Yes.
does this enable very much that kind of workflows?
It does, yes. So at the moment, we've been obviously maturing our business from concepts with our assets to moving into operations and maintenance phase. So again, with our Explorer, this allows our stakeholders to see the different stages of the assets, plan accordingly, and also to be able to share this with our ecosystem, whether that's within Enowa, within NEOM and our other sectors, and also with our consultants and contractors. As part of that as well, we've augmented our current data model, again, to fit the needs of the business. Because we're moving into an O&M stage, and we'll be integrating with other enterprise systems such as EMs, we've had to augment our data model to fit the needs of the business and our stakeholders.
And again, maybe come into the reality capture, because I've mentioned that a lot, and you probably, I mean, everyone kind of does a pre-survey to kind of understand exactly what's the underlying environment before you start, again, even start planning anything. Is that something that you focus usually on as a water organization?
Yes. So as part of that, we use SIM2 technology as part of our LiDAR 3D scanning. So we scan our facilities. It might be a pump station, it might be a tanker filling station, also our point assets, which could be our chambers. That gives us the 3D capabilities and also the accuracy of our assets, which we can double check in our GIS as part of a QA/QC check as well. Going further, using SIM2, we can also use it from a health and safety perspective. So with any new joiners within our teams, they can see the facilities before going to site and get an appreciation of the layout of that facility as well. So it's extremely beneficial.
Yeah, and I think like organizations such as ROKN, for instance, you kind of develop, you obviously work on different projects, so as yourself as well, different projects, but within sort of the same context, the same authority, let's say, that kind of regulates things across to a certain extent. But in ROKN, you move from one district to the other, from different development authorities, work with different, very different environments. And how do you see that kind of pre-survey side of things kind of being? Obviously, you're not always provided with updated data in the areas where you're going to build and design and plan things. But do you focus very much on the pre-survey element? Do you kind of go and I mean, how do you go around doing that?
Thank you, Adil. Yes, of course. I mean, we do have agreements with some of the governmental agencies that allow us to get data about the areas we're developing, but that would not be enough to understand fully the site before we take the decision on whether we will invest in it or not, whether what to design it for, and what kind of products it can take. So what we do is we run a drone survey and land survey. We collect data. We use drone to map or Reality Studio to generate multiple products out of the drone imagery, whether from 3D meshes, DTMs, DEMs, DSMs, and the whole set of products. That would help our designers, our decision makers in-house to better understand the site, to better design a master plan that fits the environment it is going to be built in. That, of course, along with the mass of data that we have on our portal that allows our business units to assess better the environment and the previous studies that were done by our market research on that area.
Okay, so verify basically the data and the information, the kind of intelligence that you got about the area beforehand, right?
Exactly. Yeah.
Maybe another point maybe is it's after the survey side of things is the master planning, and as I said, like it's always a massive challenge to kind of share master plans, version them in the right way, make sure that they're being developed and they evolve across the organization in a way where it's communicated to everyone. How do you kind of handle the version of it? I know you have a bit more control to a certain extent, but again, across different teams, how does that work? Is it relatively easy, or is it a big challenge?
Well, just like any other master planner, we do have a lot of versions that come along during the life cycle of a project. Yes, we do have applications on GIS that allow developers, development management teams to review master plans, suggest changes, and manage the changes on GIS. We're working now on an application that uses Workflow Manager along with ArcGIS Urban that allows us to control those changes from different teams and unify them sort of with a bigger view of the changes that are coming up.
Okay, and is that, because that's for NOAA is a slightly different scenario for you. You kind of you don't do your master plan, you do your planning for your assets and how you're going to lay them and kind of manage them in the future and so on. But how do you coordinate again with those very different teams that on different projects that kind of do things across in NEOM as a whole?
So again, with our data, we work closely with the other sectors, or whether it's our consultants as well. We share our web mapping as well with them. So again, we can collaborate in one platform rather than having separate platforms, and sharing our data as well with everyone.
Okay, but the master plan, the sort of, let's say, the planning, regional planning department, so that kind of comes up with that plan, do you still get versions of that and you kind of get updates, kind of links to that and overlay that with your plan, right?
Exactly, yeah. So when the changes happen, that data is sent to all the different sectors, it's shared on the map, and then that means all of our stakeholders can see that data when these changes are applied, and carry out the different workflows that are required there as well.
Okay.
As part of their roles. Yeah.
Right. I think maybe part of that as well is things like, for example, the Red Sea. When you open up, because you have again you split like a few other organizations like yourselves as well into an authority and a company. How does that kind of split help the as you see? How does it help? How does the authority ensure that that split makes sure that operations and construction and all this kind of stuff is done in a way that you yourself as an authority can manage the Red Sea or as a whole in terms of it being converted into a city that's going to run in its own respect, have the latest, again, master plan changes, the latest kind of the developments and again, designs that have been implemented. Is that something that you bear in mind? I mean, if I can pass a mic to you, if you don't mind, sorry.
Thank you. So we have certain guidelines for alignments. So when the designs are submitted, we cross-refer them with the master plans and other regional constraints to verify if they are aligned.
Okay, and also speaking of that, there's the move in. I think I've heard discussions on again working with RER, with the real estate registry, and I think you probably all kind of most of you kind of start working once you're done with your plans, once your things are being built. You kind of maintain a version, or you hand that over to RER, and you kind of make sure that kind of land information system is maintained with them. How do you? Is that link already existent, and is it something that you feel could be made better in a certain way, or is how easy is it to kind of maintain that kind of link with RER?
See, real estate management is a little different from the regular GIS cadastral data. So in real estate management, we have different versions based on the processes that are taking place at a certain point in time. So what we do is we keep data according to certain time slots. So when there is a requirement to integrate with RER on a national level, the data is exported for a certain snapshot. Now, when the snapshot changes and we believe that now there's a requirement to upload the latest data, we do that, or we have the provision to do that. But here the primary focus is to have compatibility. Like we should have certain data compliance where national level integration is possible. So although RER will have the final authority to house the cadastral data on a national level, but at certain points in time, we'll have the current snapshots stored in our local repository, which should be compliant with the national standards.
Okay.
So wherever there's a need, we can upload.
Yeah.
You know, that kind of an arrangement.
Yeah, and I think with maybe come back here is with Roshan, it's a bit again different. It's not one project, so it's not one streamline. But how do you regulate that across different projects? So whenever you hand over things, it just gets uploaded as a snapshot again to RER, and how does that work exactly?
Well, the question has two parts. How we deal with different government agencies in different regions is one part. RER has recent best standards that fit every region, right? They're unified across the entire kingdom.
Okay.
And what we worked on in the beginning with RER was aligning our standards, so whatever we have works well with them. Now, dealing with different amanas in different regions, yes, it has some differences, and we have our standards that are made in a way that can work with all the amanas across different regions. However, this is still a challenge. It takes an extra time by the contractors, depending on which project they're working on, to refine their submittals to Amana before they submit them.
Right.
But for RER, we don't have that issue.
Okay, yeah, okay. It seems like RER, I mean, from what we've seen on stage as well, they are very equipped with open standards, and which, as you're saying, like it's a proof that from your side, as another organization that works with it, it kind of makes life easier for you to kind of deal with them. Maybe another question, maybe again to Nina, is around the kind of your Enowa goals again and the sustainability angle of things. Do you how do you see yourself kind of designing and planning better to kind of achieve those goals?
Yeah. So one of our goals with our water supplies, zero liquid discharge. So that's something that we're actively using. Obviously, Esri platform, the different applications that we've created, whether it's within field maps, where engineers can go out to site and to check as well, our pipelines, and also we're looking to use AI as well as part of that, and develop the field maps with that.
Yeah. Okay. So it's very much kind of GIS-centric in that sense.
Yes.
All right, that's good to know. Do you guys have any questions? I think I'm just trying to open it a little bit. I know anything that you would like to ask again each other about, or ask in general. Any challenges you see in the sustainability angle, in hurdles or things that might be impeding again you doing your planning, or again the master plan kind of challenges that you get with the planning departments and things of that sort? Yeah.
Also from NEOM, just a comment that we have on the onset quite detailed requirements related to deliverables related to GIS and BIM. And the challenge that I think is available for almost everyone is that to combine these two worlds. You know, so I understand that Esri is doing some effort to make it more, how to say, transparent. But as of now, it's like two worlds. Yeah.
Yeah.
On that point, actually, what we did was we combined both teams under one department. That solves a lot.
I mean, not everyone has that luxury, but
there's a lot of synergy once you do that. Having two teams working in parallel, yes, it has its benefits, but once you combine them and work on the same direction in terms of technology adoption, in terms of solution designing for the business, you get a lot of synergy.
Yeah, and I think as well as it's in the end of the day, it's all about stakeholder this collaboration, and getting them basically getting their buy-in of saying like, well, the benefits for the designer side of things is A, B, and C. The benefits for the GIS side of things is again A, B, and C. I think the GIS guys are more bought on it because they see the GIS picture, which is like not just the planning and designing side of things, but they see also the operation and maintenance, the rest of the ecosystems, or the rest of the workflow. So they understand the bigger picture, whereas designers just want to do their job, want to do it perfectly and submit it that way. And again, I think the next session would be part of it would be focused on the GIS BIM integration per se and the benefits of it. But again, in a nutshell, it really depends on how you want that integration to be. From what we've seen, I think, and from many discussions we've had over the past day and a half, these kind of integrations could be very timely, and they need to happen right away in certain times of the some phases, like design phases, when designs change all the time, or they could be very sporadic, like whenever a huge change happens, and that's probably after things are built, things have been handed over. You don't really need to update the BIM anymore on the GIS unless a major change to the building happens and a new BIM is submitted and so forth. So it really depends. And again, benefits for GIS side of things is obviously clear because you have the BIM where if you want to do, again, any maintenance works, you know exactly what parts of the that structure you've got, what kind of elements and all the kind of the ERP system behind that relates to that detailed structure. But for the BIM guys as well, it's understanding the context, which is what I've started the presentation with. It's the context of your design, the bigger picture, not just going to gaming engines and all that fancy stuff, but just basic 3D. How does this fall within the bigger environment, within the bigger plan? Also, the impact of my design on other things like shade analysis, like view sheds, and what do you see from different floors? Those kind of elements. So there's a lot of advantages on both ends. There's obviously there's also a nice kind of brochure booklet that kind of has been produced by Geospatial World, one of the organizations that kind of focuses on geospatial specifically, where they kind of outlined all the kind of benefits again of the integration of both worlds together. In our platform, as far as the technology is involved, it's an easy integration depending on obviously what part of the workflow you're going to put it in, but it's easy to kind of bring both worlds with each other, not necessarily simultaneous in the easy now. All right, so I think, started 5 minutes late, ended 5 minutes late. So I'll give you that break until the next session. I think the next session now will be on construction management and design, and that will happen at 3 o'clock. So thank you very much for being here. Thanks very much for listening to me, but also thanks very much for our speakers.
نبدأ؟ اوكي. طيب. مش هستأذنكم نقفل الباب؟ معلش. شكرا. اتفضل. كده شغال؟ شغال؟ اوكي. طيب. كده سامعين الصوت؟ اوكي. Okay, hello everyone. Thank you for staying late, and thank you for making it to attend today. More interesting and more energetic that we have a couple of success stories in a couple of giga projects in the Kingdom of Saudi Arabia, which is ROKN Medina Holding and King Salman Energy Park. So it will be not just one-way presentation. We needed to be more interactive. As well, we have 4 speakers in the upcoming 55 minutes, I believe. Cool. So. ده ازاي؟ مش شغال. خلاص مفيش مشكلة مفيش مشكلة. تمام تمام. Okay, first of all, I would like to invite you to give your feedback about this session, following the session, of course. The agenda for today will be, as you can see here, an overview about the challenge we are facing with the engineering and construction industry. Then we will have a look from 3 different perspectives. The first one from the BIM team's perspective. What is in the GIS, what's in Esri technology for the BIM team, the engineering teams. Then we will move for the project managers. So the project manager, how they can make the best use of GIS to help them to make an efficient way to manage the project in general, and specifically the engineering, the design, the construction part. Then moving to the GIS team, and I believe most of us here from this side, which is the geographic information systems. Then, and all of this will be briefly in the first around 20 minutes. Then we will move to the success stories in KSA, as I just mentioned in the opening. Then we will conclude the session, inshallah. Okay. First of all, in each built environment project, we have different teams. We have the planning team, as we have discussed in the previous session with Dr. Adel, who attended the previous session in this room, the GIS for architecture and sustainability. Hi. Cool. So we have discussed some points when it comes to how to use GIS to make the planning and the urban planning and the urban design more efficient using the GIS. And now we are moving to the design and the construction side of things. And we can see we have different teams, different phases. We have the planning, the permitting, the design, the pre-construction, the construction, and the delivery, which is the most painful part of the project. And of course, all of this for the sake of seamless operation and maintenance. So what we do, that the GIS help us to go through all of these project stages or phases to make it easier for the longest time, the longest span in the project life cycle, which is the operation. And
you can imagine all of these stages will generate different data formats. It could be 2D GIS. It could be imagery from drones. It could be laser scanning. It could be some information that we get from a satellite image, like for a terrain or a surface. It could be design formats like CAD and BIM. It could be 3D masses, just to symbolize the out shell of the building. It could be something from drones, like point cloud. It could be voxel layers for the geotechnical information or geology information. It could be texture mesh. It could be real-time information that is collected by IoT sensors and IoT devices. All of these scattered data, all of these tons of information needs to be collected with something. And our proposal that everything happens in a location, in somewhere in the world, and that's how we see that all of this can be collected through the location. So whenever we talk about a building, when we talk about a certain asset, we have a location that represents the location of this building or this asset, and this can redirect us to the information that we need regarding this particular project, and whatever it's an information related to the design, to the planning, or even the finance and the budgeting. And to do this, we have a couple of methodologies or technologies, as we can say, the BIM or the Building Information Modeling and the GIS. The BIM is more into the engineering side of things, the design side of things. And when I'm talking now about design, I'm talking about structural design, architectural design, mechanical, electrical, plumbing, and all of the engineering disciplines. And this is how the BIM help us to have the geographic side of things, the model, in addition to the information and the data. And when we move to the other aspect, which is the GIS, Geographic Information System, and I think most of us are familiar with it, the GIS help us to understand the context of the first aspect. So whenever we have a BIM model for a certain building, the GIS help us to help us to understand what's happening around this building. We don't talk about a certain tower, for example, or a certain building. We're developing huge areas in Saudi Arabia. We're talking about cities, right? We're talking Red Sea, Gidea, Neom. All of these projects needs a context to understand more how we should take our next step. So this is an overview of what's happening in the AEC cycle, or the built environment project life cycle. From BIM team's perspective or from engineering perspective, how GIS can help them. Maybe if you have attended yesterday the session with Esri and Autodesk, who have attended this session, we had a very gentleman from Autodesk side who presented yesterday on the stage how the collaboration goes now between Esri and Autodesk, and now we don't even say it like a cooperation or an integration. It's like a global alignment, because now we are trying to make both sides of technologies like one bigger ecosystem. So it's not Esri side and Autodesk side. When it comes to implement an AEC project, we consider them as one bigger ecosystem. So if you are from the BIM side, you are interested more into the design. So you might use something like AutoCAD. You might use something like Map3D, Civil 3D, InfraWorks. So whenever you use any of these tools, you can get the benefit of GIS. So you can bring the GIS data. So you can imagine if you're working, for example, in a project on Civil 3D. So you're working with water pipelines, and you need to make sure that the pipelines are in its right location, and you need to take into consideration the slope of the surface. And all of this information, you will get it from the GIS. So you don't need to collect this information from different data sources. You will just get it from the GIS, from Esri or ArcGIS Online or ArcGIS Enterprise, and it will be into your design environment. Then you can start working on your design to make it context aware, and as well for the other design tools. As there is ArcGIS Living Atlas, maybe some of you are familiar with ArcGIS Living Atlas, providing some geospatial data that are ready to use, so you can get access to ArcGIS Living Atlas inside your environment. So you can get access to the GIS data, ArcGIS Living Atlas data, and you can get access to Esri maps in your design environment. And here's an example. Now you can, this is a civil 3D site drawing. You can connect to what we call Autodesk connector for ArcGIS. Here's the button. And whenever you click, you get the ArcGIS Online or ArcGIS Enterprise interface. You can go to the feature or the area of interest. You can choose the point or the line or whatever, and you can do the mapping between the feature in the GIS and what is the relevant feature on the BIM side. Because as you know, the BIM has its own schema, fixed schema. Unlike the GIS, it's open. So you can get some, for example, some points, and you can choose that these points are representing the manholes in the BIM side. Or you can get some lines, and you choose that they are representing the pipelines on the BIM side. And that's how they are connected. You can edit some information. Maybe it could be a tabular data. It could be geometry. And whatever you update on the civil 3D side or the design side, it will be reflected onto the GIS. So whatever you do on the design side, it will be reflected to the GIS side and vice versa. So if there's someone from the GIS team made some change, it will be reflected as well to the BIM side. And here's a question. Here it is again. We will modify the attributes from the BIM that was published inside the GIS. And here's a question. What if we have multiple versions? If there is someone from the BIM team edited something and the GIS team edited something, here comes the multi-user databases. So it works as well in this realm. So whenever you update something in Civil 3D and you just publish it on the ArcGIS Enterprise, you have a database admin that will reject and accept different and compare between the different versions. So the versioning as well works in this space. Okay. On the right side, we have a screenshot from InfraWorks, and it works the same way as the Civil 3D. Okay, and publish the project. In addition to having the data inside, having access to the data on ArcGIS inside the design environment, you can get some ArcGIS tools inside your design environment. And we have ArcGIS AutoCAD, ArcGIS for AutoCAD. It's an old plugin. It's here since years ago, even before the collaboration between the two companies, and it's a free plugin. So if you have Autodesk license now, you can just download ArcGIS AutoCAD, and you can do some data manipulation or some editing or some basic analysis, geospatial analysis inside your design tools. So you're bringing even not just the data, some tools, some basic tools to start working with the GIS data inside the Autodesk side of things. So this is from BIM perspective. Now we're moving for the project managers. The project managers, they're more into the bigger picture, right? They need to oversee what's happening in the site, what's happening in the design, what's happening in the construction. So they need to have something like this discovery questions. And I can tell that this type of questions can help a lot of projects and a lot of project managers to not to struggle when they start working on the project. Something like, are there BIM CAD GIS standards? Are there some standards that we need to comply to? Is there some coordinate system that we all agree that we will use? Or the BIM team will just create the building in whatever they want in the 0, 0 point? And when we get it to the JS side, we will just look in the sea, somewhere in the ocean, somewhere in Africa and Latin America, and it's here in Saudi Arabia. It's supposed to be here. And I can see some smiling faces, so I'm sure that you're facing these problems in your projects. So this kind of discovery questions can help us to take considerations even before the project starts. So what's in the JS for the project managers? We care about this integration, the JS and BIM part. We even dedicated a product for this. We call it RCJY. So the name, even the name representing the concept. And what's the ArcGIS-GeoBIM? As you can see here, ArcGIS-GeoBIM is a dual view. It's a cloud-to-cloud integration between Autodesk Construction Cloud and BIM 360 and ArcGIS Online or ArcGIS Enterprise. And this is the news that maybe some of you didn't hear about, that now you can work with ArcGIS-GeoBIM on ArcGIS Enterprise, on premises, on the server, not just a cloud-to-cloud collaboration. So on the left side, you can see ArcGIS viewer, and on the right side, you can see the Autodesk Construction viewer. And it's not just a dual view. If you click on any element, and I'm not talking buildings, any element on the door or floor or whatever, it will be open and selected on the other side. And it's not just about the viewers. It can be connected with some drawings, some PDF, some related document on the other side, on the BIM side. Okay, cool. Now we have an overview of what's happening on the GIS side and on the BIM side. It's not just about that. As well, we can get use of the issue clustering. So what's issue clustering? We know do we have someone from BIM teams here? Cool. So in the BIM teams, there is the collaboration part. So we have in the clash detection, we can say for the same discipline, within the same discipline, like electrical discipline, and we have another clash detection or collaboration between different disciplines. And this way we can predict what's wrong, not predict, we can get what's wrong with the design, what's the conflicts between the different designs. And this way we can take it further for the geospatial discipline. So whenever you finish the collaboration and the clash detection between different disciplines, you can take it to the GIS, and the GIS can tell you, no, this building is exceeding the dedicated land parcel. So this is an issue, right? Or maybe the BIM team needs to raise some issue as well from their side. And both issues will be clustered and viewed like what we see here, and we can even get a dashboard or some indicators that show the KPIs from the clusters from both teams. Whenever the GIS team raises an issue, it will be as well reflected into Autodesk Construction Cloud. So even the BIM team, if they don't use the ArcGIS-GeoBIM, they will see the issue that was raised by the GIS team, and vice versa. Dashboards. So when we talk project management, we need dashboards. Okay. Okay. How can dashboards help project managers? Dashboards give you a quick information about the whole project, what's going on, the inspection status, what's active permits right now, and we're taking it for further usage. Now you can visualize the real-time movement of the vehicles or the field workers. So it's not just about having a beautiful map. No, we're taking it more into twinning what's happening in the real world. So if there is some movement, if you have some sensor that you need to visualize what's the feed that is collected, you can visualize it in real time on the dashboard. I will repeat it again, just to show to you the movement. You can see here the movement of the field workers. Okay? And just one case. Okay, one more thing, how we can do some construction monitoring with drones. We need to help the project managers to monitor the project even if they are not on the site. So this is a real website. I can share the link with you. If you're interested, you can just send me a message or an email. I can send this website, this application to you. This is to manage the construction of our head office in Redlands using drones. So here we can see that this was just a parking area. Then when we go forward into the date, we can see some excavation work started. And it was collected with drones. And we can use this to make the geospatial coordination with the BIM design. And you can see here that you can get the information of the BIM, as well you can get the phasing information. So if the building elements are connected to the phase that it will be, when it will be executed, it will be connected here. So you can filter using the level, using the construction phase as you want. And if we go forward, more forward to into the date, you can see the as-is, or the as-built, the finished work by the end of the project. So you can see here is the BIM, and this is the 3D mesh that was collected using the drones. Project management, so Primavera, Oracle Primavera P6. Now we have an integration with some dedicated tools inside the ArcGIS to get the information from project, from Oracle P6, Primavera P6, and to be visualized on the map and on the ArcGIS dashboards. And this dashboard is ArcGIS based, the map is ArcGIS based, so you just need to get the information from the Oracle side, and it will be visualized here using this beautiful dashboard. The GIS team, and I will not talk a lot about the GIS team, I'm sure you are experts. So the GIS team, now you can work with the different data formats from the design side. You can work with Revit, RVT files, you can work with IFC, which is the open standard format for the whole industry. You can work with DWG, whatever it's exported from a BIM software like Civil 3D or from AutoCAD, DGN, like other CAD formats, or of course Civil 3D as we mentioned. Now from ArcGIS Pro you can connect to the BIM 360 from ArcGIS Pro and to get the information from the Autodesk Construction Cloud or BIM 360 and start working on it on the ArcGIS side. So it's similar to Autodesk connector for ArcGIS. ArcGIS Pro can understand or interpret the different elements inside the Revit file, whatever it's the discipline like architecture, it will be translated to feature dataset. The category like doors will be translated to feature class. The family like double glass door or single flush door, it will be an attribute, and the type will be as well an attribute. And the whole other elements, it will be something like this. It's like a dictionary between the two sides. And this as well works for the IFC. IFC, which is the open standard, so it's not related to Autodesk. So you can work with whatever design software vendor you want, and you will export the data in IFC. It could be something from Autodesk, from Bentley, from ArchiCAD, from Hexagon, from Dassault, or whatever software you use. You just get us the IFC, which is the open standard, and you can work with it inside the ArcGIS Pro, as you can see here. ArcGIS Pro as well can work with the infrastructure BIM drawings like Civil 3D. So here's another dictionary between how Civil 3D digest or understand the elements on the design side, and how Esri can understand or translate what's from Autodesk side, Autodesk Civil 3D side, to Esri geometry, whatever it's point, line, polygon, or multi-patch. And this is how the advancements arrived so far when it comes to the engineering and construction. We talked from BIM side of things, we talked from GIS side of things, and from the perspective of project managers. And now, as we promised, we have success stories. We will not talk more about Esri technology. We all know that Esri technology is beautiful, but now we will talk more about how you can utilize Esri technology in real projects, in giga projects in Saudi Arabia. And that's how I would like to introduce Mr. Ahmed Khalifa, the engineering director of Spark. Please.
Assalamu alaikum. Today I will present the showcase of Spark success story so far, alhamdulillah. The idea of the project of Spark, or briefly, Spark is the King Salman Energy Park, located in Eastern Province. It's industrial world-class hub, divided for 3 phases. Phase 1, it's around 18-kilometer land, and covers like 280 plus interface or stakeholder included in phase 1. So the project here, the driver of this project is the absence or uncontrolled data. We have heard multiple times data information so far. So in order to control the data, in order to control or to build a single source of truth of the information for the project, we have created a Spark GeoBIM database or Spark GeoBIM information model. So currently, we almost reach 80% of the construction or the project execution. The Spark GeoBIM output or key output is divided in different outputs. We started with developing CAD and BIM and GIS standard for Spark project. So currently, we have our own standard specialized for Spark. And then built on this standard, we have created the geodatabase design, and also we have created the GIS roadmap development in order to reach the full digital twin by 2028, inshallah. So in order to build the GIS roadmap, we have conducted fact-finding for the project, and also the site or the situation assessment for all the stakeholders, which is almost 280 plus stakeholders in the project. And also we determine the future status, what we need to be there. And finally, we develop the GIS roadmap in order to reach the full digital twin application by 2028. And this is an example of the geodatabase design. And this area shows the integration or the stakeholder, the BIM contractor, the contractors, the survey, geometric survey division, and the construction project management team. And this is the work process, starting from the data collection. We collect the data, or we convert the data from the as-built. Almost the as-built of the project, it's around 4,000 plus drawing. We have converted all of this information from PDF, from CAD to GIS. And also we captured all the unavailable data through drones or through ground penetration survey. So this is how we integrate the drones to our platform. And this finally will be the dashboard or the themes of the dashboard, and it is flexible and agile, so we can agile it, or we can specify the user interface. So starting from the planning stage, from the master plan, we have implemented some of regulation and permitting on the database itself, and then goes through design, construction, and end with the operation. And this is where we have developed, or we have integrated the 2D and 3D viewer. And the other side is the master dashboard, where the decision maker can build their decision accordingly. And one of the main, let's say, gaps bridged by this project is the interface management between the stakeholders. And all the construction team understands that one of the main problems in the project is the tie-in point and the interface between the tenant or the site developer and the infrastructure. By these tools or by this project, we bridge the gap. So all the stakeholders can emphasize or can visualize the design before the construction, and even after the construction, any developer can take the land and he can visualize the infrastructure and the tie-in point before signing for the land. This is one of the output of the project is a wayfinding application we developed in the project. The wayfinding it's more detailed, more specific for Spark. So it is already connected with the asset management or the asset list of the project. So you can navigate whatever you want. Fire hydrant by number of fire hydrant, by number of street lighting pole, by number of manhole. You can navigate up to the location of the manhole. And on the right side, AMCO, for example, it's one of our developer or one of the parcels developer. Once you collect by using the wayfinding, you can see all the attributes related to this building, all the attributes related to the developers, and all the information. This is a virtual reality since we already built the information system and integrate the GeoPIM and GIS. As Hisham mentioned, it's not now just only an idea of integrating BIM and GIS. We already implemented. Now this project, it's already 80% implemented now. Inshallah, it will go live next month. So we already built also the virtual reality, so you can predict and you can visualize the interface between all the stakeholders on the spot, even before the construction. And this is the conclusion of the integration, integrating the GeoPIM or integrating the GIS with the PIM. So we are targeting to automate the checklist, targeting to automate the review of the design. So the design, once we create the PIM template, so any developer in the city can populate the model directly to the platform and automatically could be checked. So it will give you the uncompliance point on the spot. So any uncompliance point, it will be shown on the platform directly. And second point, it also supports for operation and maintenance asset and informed decision making. It could and it will create a reliable source of a single source of information, single source of truth for the project information, considering the type of different stakeholders in the project. It is enhanced site selection and planning, improve the design coordination and sort out the clash analysis between different disciplines, even the underground and above ground utilities, improve the design coordination, and finally enhance the communication and collaboration between all the stakeholders in the project. With this, I conclude my presentation, and back to you, Hisham. Hisham, back to you.
Thank you. I believe it's becoming more interesting, right? So now we're about from the team of the Geo Excellence Award winner, the ROKN Medina Holding, and we were here now from from Mr. Tamer Al-Gohari, Digital Innovation Manager of ROKN Medina, and Mr. Bandar Al-Misbahi, GIS Manager of ROKN Medina.
Hello everyone. First of all, I would like to thank Esri for giving us this opportunity today to be here and showcase ROKN Medina achievements within the GIS. Starting with ROKN Medina. ROKN Medina is one of the PIF companies. We are based in Medina Munawwara, the city of Prophet Muhammad sallallahu alaihi wasallam. Our main business is real estate and investment. So we have a portfolio of projects. However, our biggest project called RAM, as we are developing the eastern side from Al-Haram al-Nabawi Sharif This project is going to be constructed over 1.4 million meters square, which make it as one of the biggest, or let's say, one of the giga projects in terms of hospitality within the region. So we are committed by 2030 to deliver 47,000 keys, and this is a huge number of hotel apartments that are going to be delivered by ROKN Medina. These are our two giga projects. The first one, as I said, it's RAM on the eastern side of Al Masjid Nabawi Sharif. The other one is Dar Al Hijra. This, again, hospitality project that's going to be constructed over 147 meters square of land. Given the size of the projects that we have, it was very essential to have a GIS enterprise system to manage, to analyze, and to support the decision makers of operating this project. That's why we started the journey 2 years ago by an internal assessment for our GIS capabilities. So the first step was the internal assessment, and further to that assessment to figure out that we need to have a GIS enterprise system to be implemented, and also within this GIS enterprise system we need to have application, different dashboards. So the ultimate goal of this is to make the GIS information available for everyone within ROKN Medina, and also it have to be accessible and very easy to visualize as well. So finally, our approach and recommendation is to appoint the technology GIS partner, and that was Esri, and also to appoint an implementation partner, and Isaac was the consultant that have been working with us side by side during this project. So me personally, we have chosen Esri, and I was supporting Esri much in here because the advancement of the GIS technologies that they have. So over the past yesterday and today, we have seen a lot of applications, their roadmaps. So Esri is always on the edge of the GIS technology. Here I'm going to show you and share with you some of the numbers that we got since we published our GeoPortal last September, starting from the end. For example, we got 2,000 viewers for the GeoPortal, and given the number of employees in ROKN Medina, this is a very huge number. The top one application that we have is ROA Building Viewer, where we are combining the 3D mesh, the drone capture with the BEM. And we got 1,700 viewers in 3 months. And let me tell you that right now in ROKN Medina, there is no coordination meeting, interface meeting, even meetings with the CEO. Everyone is using the GeoPortal to track the progress on the site. So we're imposing the BEM model during the design with the actual status of the site. And I have two very valid use cases where the GeoPortal supported the decision making of starting the projects or even redesigning the project. The second dashboard that we have here is the program dashboard, where we are updating this bi-weekly. So right now, anyone in ROKN Medina, if you want to get any information about the progress, either construction, design, etc., you can log into the dashboard. Third one is ROA Map Explorer, where we have the master plan and we have the updated design master plan in that application. Lastly is the property management dashboard. So within dashboard, we have all the properties and assets in ROKN Medina. The number is 151 because it's exclusively for the property management team, where they can log in, they will find the dashboard, every single asset. You can't click on the asset, you will get the full information updated monthly. I will pass now to my colleague Bander to take you on the live use case.
Thank you, Tamer. Great introduction, really. Actually, we were, as Tamer mentioned, we were lucky to implement our enterprise system and GIS technology and Esri technology, and it's not okay. And Esri technology, and we were lucky to have our implementation partner, as Tamer said, Isaac. We have built our enterprise with some applications that we are very proud to have them used internally for our team. Okay, and let's go for the demo, for the videos to show you some of our applications that we are proud to share. Okay, this is the interface of our enterprise, the GeoPortal. The first application is the property dashboard. The beauty of this dashboard is gathering all scattered data from different formats, PDF, Excel sheets, let's say title deeds, and all kind of CAD drawings, survey works in one interface with all related data, so it makes easier for all managers of the properties to see everything in their hand in one single interface. Second, we are going through, we don't want to make you boring. This is gathering all design drawings in addition to as-built drawings, all kind of utilities that gathered from infrastructure, delivery, construction teams. Okay, having everything in one platform, they can navigate, they can enter title deeds as well, and all utilities, infrastructure, electricity, water, potable water, storm networks, in all of them in the hands of infrastructure design team and architecture design team and construction delivery teams, so they can navigate in the required information. And there is additional tool here that is customized in this. They can print a plot ID sheet for each plot. They can see all the parameters for each parcel to be shared with any vendor, any land to be handed over for others or for sales. Third application, this is dashboard as well, but it's customized for planning team. And this shows the portfolio of ROKN Medina projects. We have three main portfolios, and the main one is ROKN Medina. They can navigate in each project under each portfolio. They see the progress and the related photos from site as well. So it's one glass. They can show the progress for each project and related data for that project. And this one is integrating the BIM model with drone photos on site. This is providing a very nice capability of integrating the BIM models with the site existing. So whenever the site team, they want to compare the design, in addition, they want to compare the design with the site existing, they just can turn on the layers and they can see if there is any deviation between the design and the site condition. In addition to the tools that Esri providing in this application, they can measure the areas and lengths and heights as well. So it is a very powerful tool that provides both, as mentioned, design team and construction team, in addition to all management team, to see the whole site condition in addition to the design drawings. Last one of our main applications that developed here is to provide, we have site offices that in-house are more than 400 employees with several number of buildings, and it was very hard actually for some people to navigate where are the employees or partners in specific departments. So this was a very and quick wayfinding for employees they can search by name, they can search by department, let's say, they can, even the facility management team, they can see by glance where are the vacancies and occupied places. Thank you very much. That's it. Thank you.
Okay, thank you. Thank you, our guest of honor speakers. Thank you for sharing your insights and how you used your imagination to make the best use of the GIS. So as Jack always mentions, that it's just limited by the user imagination, and I can see here the imagination is the sky's the limit when it comes to your case. So I would like to invite you to follow our newsletter, Esri SA AEC newsletter. It's published on LinkedIn on Esri Saudi Arabia page. So you will find it in the newsletters section on the page of Esri Saudi Arabia. We were trying to grow our community that was announced last year by Dr. Adel Bulbul in the AEC community meeting. We're trying to share more news about the latest advancements when it comes to Esri technology for the sector. We are trying to share other success stories from partners, from clients, as we saw today. So I believe that it would be beneficial. So to close, ArcGIS is one place, like a central system that can collect the data from different data sources. It could be from mobile apps like field maps, like Survey 123, like even the reality applications. And all of this data can be collected on ArcGIS. In addition to the data from the design, whatever it's RVT, IFC, whatever the system you are using, whatever for Autodesk, Hexagon, or whatever the design software you are using, it will be on the ArcGIS. In addition to extending the power of ArcGIS using the integration with Unity or Unreal Engine to have an immersive experience, whatever for construction monitoring, for the operation, or even for simulation. And of course, the management side of things, the construction project management side of things, utilizing the integration with Primavera P6 or Autodesk Construction Cloud, or using ArcGIS GeoBIM and ArcGIS dashboards. All of this will be in just one place. So if you are targeting building a digital twin, ArcGIS can be the foundation for this digital twin, or ArcGIS can be your digital twin. Thank you. Please share your feedback using this QR code, and thank you for staying this late. If you have any questions for me, for the speakers.
Okay, thanks for your presentation and information. I have two questions. I have as plan in BIM and as built in BIM, and I visualize it in GIS.
Cool.
Okay. Can I transfer indoor data from GeoBIM or BIM data to data model, indoor data model in GIS? Okay. This is the first question. Yeah. Second question, I have as planned and as built in GIM part. Can I measure the differences by spatial analysis tool in GIS?
Sorry, again, the second question.
I have as planned design and as built design in BIM. I visualize them in GIS. Okay. Can I measure the difference between as planned and as built in centimeters or millimeters to check the construction engineer deliver me what I need in as planned? Or I see the engineer use hand measure. Yeah. Can I measure automated or make a differences by any tool in GIS? Yeah. Okay. To make the differences or check the differences between the two design.
Okay. Okay. Thank you for your question. For the first question, when it comes to building an indoor map, so this is one other application that we didn't mention today, to have an indoor map maybe for further usage, like something like a map for the airport. So you can imagine if you're in an airport and you're late and you are looking for the right gate, so you'll just open your map and click gate 3 and it will take you to the gate. This is one application of ArcGIS Indoors. So to use ArcGIS Indoors or to create an indoor map, you have 3 ways. You can create it from scratch inside ArcGIS like any other map. You can use the AutoCAD drawings for the building, and actually now there is Indoors plugin. You can use it inside AutoCAD, so it can help you to choose the right layers on AutoCAD, right layers, so it can be mapped in easy way to ArcGIS Indoors. And the third one is to transform the BIM to indoor model. So whenever you bring actually this is the easiest way from the 3, because the indoor space is already created. So whenever you bring it to ArcGIS Pro, with just few clicks, it will be transferred to indoors data set. It can be, of course, 100%, and this is the easiest way. For the second question, when it comes to measuring differences between different models as planned and as built and during and in progress, of course it can be done to a certain extent, but when it comes to more detailed comparison, you will need to go to the home environment for the design, which is the design environment or the BIM environment. But it can be done, of course, when it comes to not very detailed measurements. Thank you.
Thanks for your presentation today. As I say now, as I am a GIS user, I can use ArcPro to make all of my works. I see integration comes in two-way integration between BIM applications like Revit, Civil 3D on platform.
Yeah.
The two ways it was cloud platform. For in case I want to work on ArcGIS Pro and want to integrate these solutions on my desktop.
Yeah.
Is it accessible?
Okay, so thank you for the question. So the question is that the integration is from ArcGIS side, it's on cloud and on-prem. So you can use the integration on ArcGIS on on-premises server or on cloud. But from the BIM side, right? This is the question. Because the integration with Autodesk Construction Cloud or BIM 360, and they are on the cloud, right? Okay, cool. For now, no, it cannot be done. You need to have a subscription for Autodesk Construction Cloud or BIM 360, so it's cloud-based. So for now, no, you can't do that. But there is some other ways and some future plans, so you can have both sides of ArcGIS GeoBIM on-prem. But this is something like future plan. Thank you.
Thank you. Regarding the integration with project management software like Primavera or Oracle, is it implemented in the latest versions of ArcGIS Enterprise? Does it need license?
Which product?
Any project management software.
Okay.
As I see, you integrated with scheduling software.
Yeah.
It was Oracle, I think.
Yeah, exactly.
So this integration is custom integration or is it built in within the ArcGIS Enterprise? Does it need license starting from which version?
Okay, thank you. Yeah, we have developed some ready-to-use scripts and some ready-to-use geoprocessing tools that can help you to achieve this integration. So there is no much customization to do this type of integration with Primavera P6 or project management softwares. It's shared.
Shared? It is shared geoprocessing services or?
Yeah.
Okay, great.
Okay, thank you. Sorry.
Just a follow-up. So for the Primavera, it should be in the Oracle in the database. It's not like a file that can be processed, right? It should be published on the Oracle accessed.
Yeah. Thank you. Correct. Yeah.
But thank you for this amazing session. But my question related to their question, how can I view this from Autodesk Construction Cloud to
ArcGIS?
Yes.
Okay, thank you. Okay. There is a link?
Always I view as a link. Just when I go to that.
Exactly. Okay, so how we can visualize, and this is how we will conclude this session with this question, how we can get the information from the BI Autodesk Construction Cloud inside ArcGIS in general, not ArcGIS GeoBIM, right? So we can just connect to the BIM cloud environment and get the information inside ArcGIS Pro and start working with them. And if you need to, you can download them and upload them on ArcGIS Web Viewer. So that's how you can get the information from Autodesk Construction Cloud inside your environment. Or you can just keep the BIM models on their environment, and you keep the GIS separate, but you have ArcGIS GeoBIM to have both sides visualized and linked in the same space. Okay, cool. Cool, thank you. And that's how I believe we conclude the session and we conclude the conference. Thank you for staying too late.